Engineering Diponegoro University was established in 1958 to meet the needs of civil engineering experts in Semarang. The curriculum for the Bachelor of Civil Engineering program at Diponegoro University is designed so that graduates are able to understand the concepts. The Department of Civil Engineering Universitas Jember is part of its Faculty of Engineering. At this time, the Civil Engineering Undergraduate Study Program is accredited A by the National Accreditation Board for Higher Education. Universitas Jenderal Sudirman. The Department of Civil Engineering was established simultaneously with the Bachelor of Engineering program, which was the forerunner of the Faculty of Engineering, UNSUR. Civil Engineering UPN Veteran East Java has facilities in the form of 5 laboratories. Universitas Muhammadiyah Yogyakarta. UMY's Civil Engineering Study Program is one of the first study programs held when Muhammadiyah University of Yogyakarta was established in 1981 and has received the accreditation of Grade A. Utama Karya is a construction company whose shares are 100% owned by the Government of the Republic of Indonesia through the Ministry of State-Owned Enterprises or BUMN as shareholder. ADI's status as a limited liability company encourages ADI to continue to provide the best for every stakeholder during the development of ADI and the growing construction industry in Indonesia. The intensity of competition and price wars between the construction industries has made the company redefine its vision and mission. PT Waskita Karya Tbk, a state-controlled company, is an Indonesian general contractor engaged in a wide range of construction activities including highways, bridges, buildings, facilities. PT Wijaya Karya Rekayasa Konstruksi or Wikarekon is a subsidiary of PT Wijaya Karya Persero Tbk or Wika, which is designed to be an integrated, aggressive, innovative, and professional company.
Halo, cek. Mario? Excel?
Iya, Pak.
Can you hear me?
Yes, sir. You are
Okay.
audible.
Oh, okay. Hello, Dr. Lansiho. Good afternoon, sir.
Yes, thank you. Good afternoon.
Okay. We will start. Ladies and gentlemen, may I have your attention, please? The presentation in Paralel Class B is about to begin. Thank you very much for preparing yourself to join this conference. We will be hearing a presentation from Dr. Lan Siho. He is here now, but before we get started, I want to take a few minutes of your time. Firstly, I want to check all of the presenters in Parallel Class B. Are they already in this room? Mario? Vincent, maybe please help me to check if all of the presenters are in the room. Okay, I want to check on by one, all of the presenters in this class. The first presenter is Mr. Didi S. Agusta Wijaya. Are you already in this room, Mr. Didi?
Yes, I'm here. Thank you.
Thank you very much. The second presenter is Yeri Kahaditu Firmansyah. Are you already here? Mr. Yeri Kahaditu Firmansyah. Are you already here? Not yet. Dian Setiawan or Mr. Firman Sarif, are you ready for the third presenter? Okay, there's Putu Tantri Kumalasari is the fourth presenter. Are you already in this room?
Yes.
Putu. Okay, thank you.
Yeah.
The fifth presenter is Siti Nurlita Fitri. Are you already in this room?
Mrs. Siti Nurlita is trying to join, sir.
Oh, okay. Johnny Fitra is the sixth presenter. Are you ready? Yes, I can see you, Mr. Johnny Fitra. Please. Okay, thank you. Okay, Ria Restu Marlanin Tias. Are you ready for the seventh presenter? Ria Restu. Not yet. Okay. The last presenter is Prof. Windu Partono.
Yes, I'm ready.
Are you ready? Okay, thank you,
Not
Prof.
prof, yeah, not prof, not prof.
Oh, no, okay.
Senior lecturers.
Okay, senior lecture. Okay. Okay, I'm sorry because the committee changed the order of presenter based on the completeness of the presentation file and video file that you submitted on the website. So because Ms. Ria Restu and Dr. Windu Partono had not completed their presentation file until yesterday afternoon, so the committee decided that the time for your presentation will be placed at the end of the parallel session.
Okay, thank you.
Okay. Secondly, I will read the parallel session rules at this conference. Wait a moment. Maybe Mario can show the. Okay. Thank you, Mario. Parallel session rules. First, the parallel session will start on time. And then second, participant ID in this event must use a real name. Yes, not a device name or institution name. To make it easier for the committee, please follow the name format, ID paper, and then followed by presenter's name. So please change your name with this format. Yes, Siti Nurlita Fitri, maybe you can change your format ID, participant ID with ID paper and presenter's name. Okay, thank you. Third, participants who join to the meeting must dress modestly and behave politely during the event. Four, participants are strongly encouraged to mute the speaker during the running event. Parallel session day 1 consists of 5 virtual classes and is divided into 2 rounds, first round and the second round. First round is currently ongoing this time, and the second round will start at 3:15 p.m. And 6, parallel session day 2 consists of 4 virtual classes and only 1 round. 7, this is important for us, for the presenter. Duration for a parallel session is 7 minutes presentation with pre-recorded video or live presentation. Then followed by 5 minutes discussion. So total time is 12 minutes per presenter. And then 8, how to ask questions or make comments is as follows. During the presentation, question can be asked through Q&A, and then presenter will try to answer in the Q&A session. If the question has not been answered during the Q&A session due to time constraints, the presenter is expected to answer the question through the chat menu. Okay, is that clear, everyone?
Okay, clear.
Okay, thank you. Okay, now we can begin our parallel session, class B. Bismillahirrahmanirrahim. Respectable, our invited speaker is Dr. Lansiho, the Honorable all presenters of the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, and the Honorable all participants of this conference. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Welcome to Parallel Session Class B. Thank you all. Okay. Thank you all for finding the time and visiting today's conference. My name is Sepli Kayadi, and I'm a lecturer at Universitas Muhammadiyah Yogyakarta, and I will be serving as your moderator today. Okay, first of all, I would like to welcome you all to this parallel session. On this occasion, we would like to have an opening presentation from our invited speaker, Dr. Lan Siho. Before the presentation begins, allow me to introduce our invited speaker curriculum vitae. This Mr. Mario, and can you show me the curriculum vitae for? Okay, thank you. This is Dr. Lan Siho. He is the lecturer, Faculty of Civil Engineering, University of Transport Technology, Hanoi, Vietnam. Dr. Lan Siho, also an assistant professor at Department of Civil and Environmental Engineering, Hiroshima University, Japan. His educational qualification are as follows. Okay, bachelor degree from undergraduate course, Faculty of Civil Engineering, University of Transport and Communication, Hanoi, Vietnam. Master degree from graduate course, Faculty of Civil Engineering, University of Transport and Communications, Hanoi, Vietnam. And doctoral degree from Department of Civil and Environmental Engineering, Graduate School of Engineering, Hiroshima University, Japan. Without further ado, I would like to welcome to invited speaker to deliver the presentation. All right, Dr. Lansiho, the stage is yours.
Okay, so thank you very much for the introduction about me. In fact, that it is my great honor to be here to present my research. As you know, because we are facing to pandemics, and I know that now the condition in Indonesia is not so good. But I hope that all of us we will recover soon of the pandemic, and in the future, I hope maybe 3 years later, if the conference will be also held offline in Indonesia, I will take the chance to visit. So thank you very much. Should I present directly, or you can open the video? Hello.
Mario, please. Excel. Video from Dr. Lansiho.
All right, thank you. Hello, everybody. My name is Lansiho. So now I would like to present our study. The name of our study, mechanical property of the fine-grained concrete using fire red sand and fly ash for road construction, a case study in Vietnam. So this is the name of the outgrowth. First of all, I would like to begin the introduction. And you know, the traditional concrete generally includes coarse aggregates, fine aggregates, cement, water, and as you know, the strength of the concrete may be attributed to the coarse aggregate and the bonding between the cement and coarse aggregates. And the right side picture show the typical mixed proportion of concrete. So it includes the gravel or crushed stone. Fine aggregate in here, generally we use the sand, water, and Portland cement. And as you know, producing cement and exploiting aggregate like cut stone, river sand, cause many environment problems such as air pollution and depletion of resources like this one. In addition, fly ash from thermal power plant also lead to environmental problem if it had not been treated appropriately. So to reduce the environment problem, it is needed to replace cement by fly ash or other pozzolan material and replacement of coarse aggregates and river sand by other waste material to produce friendly construction material. As a result, fine-grained concrete, or in other name called by the sand concrete, were introduced. In fact, this sand concrete does not consider the coarse aggregates and mainly contain the fine aggregate and waste material. And in here, the fire aggregate included dune sand, sea sand, and waste material including like fly ash or slag. So this is a picture of the component of the sand concrete. For example, it contains the cement, dune sand, fly ash, water. Then after mixing and producing, we can prepare this kind of fine-grained concrete or sand concrete. A previous study used the 5 sand in Algeria, like the dune sand and a mixture of dune sand and river sand to produce the sand concrete, and they found that this sand concrete could meet the requirement in compressive strength compared to conventional concretes. Besides, in Vietnam, there are several studies utilizing sea sand fly ash to prepare the fine-grained concrete. And they found that it is possible to produce high-strength fine-grained concrete using sea sand and fly ash. And as you know, the Vietnam have a huge sources of red dune sand and fly ash, but there are no study utilizing fly ash in combination with the red dune sand for producing sand concrete. So in our study, we aim to investigate the use of red dune sand and fly ash at a partial replacement of crushed sand and cement for the producing fine-grained concrete in the rural road pavement construction. Next, I would like to move to material methods. In material, we have the Portland cement, PC40, fly ash, class F, red dune sand, taken from the someplace in Vietnam, and crushed dune sand. And this figure shows the particle size distribution of crushed sand, red sand, and different mixture. Sorry, I already saw here. And if we look at the red sand here, so this red sand, it belongs to this kind of the five aggregates, and then we can call the 5 sand. And in chemical composition of material use, we can see the Portland cement here, fly ash. The fly ash contains the high amount of silicon and low amount of calcium oxide. And red dune sand, we can call the mainly the ghost sand or mainly the silicon oxide in here, and the 5 sand and crushed sand. In mid proportion of the concrete, we prepare for mixture. First mixture 70% of crushed sand and 30% of red dune sand. Next mixture 60% with crushed sand and 40% red sand. And third mixture is 50% crushed sand and 50% of red dune sand. And the final 40% of crushed sand and 60% of red dune sand. And we keep the same ratio of both the binder equal to 0.37. And we use 90 kilogram per cubic meter of fly ash. And also we use the admixture. And in the testing of specimen, we use the compression test and the equipment for determining elastic modulus, and also splitting tensor test and flexural strength tests. Next, I would like to present the results in discussion. First one, in a compressive strength. If we look at on the mixture, we can see that the compressive strength increased rapidly from 3 days to 28 days. And so this increase is mainly explained by the contribution of the cement hydration for the old mixture. So we see the tendencies. And if we look at the trend between the different mixture, we can see that there is a decrease in the compressive strength from 3 to 28 days. We can see that the increase in the amount of red dune sand produce a decrease in the compressive strength. And this was explained by, as you know, when we increase the amount of red dune sand, and this red dune sand have a lower strength and lower friction compared to the crushed sand. So that's why the compressive strength decrease with the increase in the amount of red dune sand. But if we look at the 28 day only for only cases, we can see that the compressive strength in on case larger than 30 megapascal. So this kind of concrete is satisfying the requirement of the concrete for the rural pavement in Vietnam and in Vietnamese standards. For the case of the elastic modulus, similar to the compressive strength, we can see that the elastic modulus decrease with the increase in the amount of red dune sand. You can see in here. So it's normally at the compressive strength. Next, I would like to mention about the splitting tensor strength. Also, we can see that from 3 days to the 20 days, the splitting tensor strength increase with the curing time. It mainly contribute to cement hydration, and we also see the same trend and tendency with the compressive strength. We can see that the increase in the amount of the red dune sand caused a decrease in the splitting tensor strength. And if we look at all the value at the end of the 20 day splitting tensor strength for the old mixture, we can see that the value is larger than 1.7 megapascal and also satisfy the requirement of Vietnamese standards or the recommendation of ASTM for the rural road pavement. For the case of the flexural strength, in here we saw the flexural strength at the end of 28 days. We can see the nearly the same tendency, that the increase in the amount of red dune sand cause the decrease in the flexural strength. For example, for period in slightly decrease and then rapidly decrease. And all of this value also satisfy requirement for rural work pavement based on the Vietnamese standard. In the requirement, the compressed strength, the flexure strength at 20 days larger than 5 megapascal. So in one of this case, it's satisfied. So in that we would like we make the relationship between compressive strength and splitting tensor strength. We can see that the splitting tensor strength grew up with an increment in the compressive strength with a high coefficient of determination that found in the normal concrete and fine grain concrete in previous research. It indicates that this fine grain concrete using red Dunsen has similar behavior compared to normal concrete or the fine concrete using the sunlight sand or season in previous study. So finally, I would like to mention the conclusion. In this study, the compressive strength, splitting tensor strength, flexure strength of fine grain concrete using red Dunsen and a partial crush and replacement, and also we use the small amount of fly ash to replace for the cement. And some main conclusion can be drawn from the study. First one, the compressive strength, splitting tensor strength, and flexure strength increase with curing time, which mainly contribute to cement hydration. And we can see that when amount of red Dunsen increase, the compressive strength, splitting and flexure strength decrease. And there is a strong correlation between the compressive strength and splitting tensor strength with a high coefficient of determination and found in the normal concrete and the fine grain concrete using CSN. Finally, the results of compressive strength, splitting tensor strength, and flexure strength satisfy the requirement of concrete using concrete used for the rural road pavement. So here are the reference. Thank you very much for the kind attention. That's the end of my presentation.
Okay. Thank you for the informative and interesting presentation, Dr. Lansiho. Let's
present our study. The name of our study, mechanical property of the fine grain concrete using
Rio, please
sand and fly ash
stop
for road
video.
construction.
Okay. Okay, thank you for the informative and interesting presentation, Dr. Lansiho. Okay, all right, ladies and gentlemen, now we have a little more time for the question and answer session. There will be for session until 1:05 p.m. So there will be, yes, there is 5 minutes, yes, for the question and answer session. Okay, please ask your question in chat or you can ask Dr. Lansiho directly. Don't forget to mention your name and your institution. Any questions?
Yeah, please. Yeah, if you have any question, please. I can answer directly.
Yes. Any question? Ladies and gentlemen, please, you can type in chat room or you can ask Dr. Lansiho directly. Okay, Dr. Lansiho, based on your presentation, sand concrete, yes, doesn't consist of coarse aggregate and contains fine aggregate and like a done sand and RC sand and otherwise materials such as fly ash or blast furnace like. Your research is about to investigate the use of red dune sand in Vietnam, right? And fly ash as a partial replacement for producing fine fine grain concrete in rural road pavement construction. But the result are the compressive strength, the elastic modulus, the splitting tensile strength, the flexural strength. All of these parameters are decreased with an increase in the red dune sand. What do you think causes this to happen? Is it related to the chemical composition of the material used, Dr. Nancy?
Okay, so thank you for the question. The question, in fact, that you know that when we increase amount of the red dune sand, so we can see that the only tendency that the strength decrease. So in here, the mainly the decrease mainly because of because if we compare the strength of this sand compared to cost aggregate, it's small. It will be smaller, and then in addition, the almost we can say the friction between particle will be reduced. So that's why the mainly in here related to particle or the geometry of particle or friction. It doesn't really related to chemical composition of the sand because the sand mainly contain the silicon oxide, so it also stable and it will not react directly with the cement hydrated product. So and we can say that the almost zero no pozzolanic reaction of this sand with the like polynite.
Okay. Okay, thank you, Doctor. This is the question from Didi Agusta Wijaya. Mr. Didi Agusta Wijaya asks, how much is the UCS for fine grain concrete related to water content?
Okay, so for example, in our study, we use the water cement ratio, water by the ratio 0.37. So in this case, we got the maximum at around 43 megapascal. But in other previous study, in also this kind of fine grain sand concrete, they use C sand and also they use the fly ash, and they can get the maximum compressive strength over 50 megapascal.
All right, thank you. That's a bit high for the UCS. Okay, thank you very much.
Okay. Are you satisfied with the presenter answer, Mr. Didi Agus?
Yes, thank you.
Okay. Okay, thank you. There is another question maybe from the another presenter. Can you ask again, Dr. Lansio? Can you ask again for you?
Yes.
Has your research been applied to? Yes. Has your research been applied to the road of pavement in Vietnam, Dr. Lansio?
Yes.
Has your research been applied to rural road pavement in Vietnam?
Yes. In fact, that this one already applied.
Okay.
Our team we already applied this kind of fine grain concrete for road pavement and many structure for the dye or for some structure near the river by using this kind of sand concrete. And now it's undergoing. We are investigating some the microstructure of the structure in the sea for maybe 5 years already, to check how about the durability of structure, like the carbonation or our chain in microstructure using the scan electron microscopy or the porosity or distribution also. So in fact, that this this one is only one small part of our project. So now we are preparing some the journal paper to submit in the Web of Science journal paper for the microstructural study of this kind of fine grain concrete. And then now this kind of concrete is quite popular in Vietnam already. So because in fact this kind of fire red dun sen in Vietnam, we have a lot in the near the south of Vietnam, in the south of Vietnam. So we are utilizing this kind of fire dun sen to replace for the cost agri and then also the crush sand also, and it's quite successful to apply for like road pavement of rural road pavement.
Okay. Okay. Thank you, Dr. Lance Iho, for your explanation. Okay. We come to the end of part of our invited speaker presentation. We would like to say thank you to Mr. Dr. Lance Iho.
Okay, thank you very
Thank
much.
you.
If you have any further question, please send the message or email. You can find my name on the Google, and then you can send me the email. Thank you.
Okay. Very welcome, Doctor. Hopefully the presentation will be beneficial for everybody. Okay. Now, ladies and gentlemen, let's welcome our first presenter. First presenter, wait a minute, Mr. Didi S. Agusta Wijaya, right? He will deliver a presentation entitled "Application of the Update PSAN on the Stability Analysis of the Meninting Diversion Tunnel in Lombok Island, Indonesia." Okay, ladies and gentlemen, please welcome Mr. Didi S. Agusta Wijaya. The stage is yours.
All right, thank you very much for Mr. Safika. I would like to present our paper, and we have already prepared the presentation using the video presentation, and now is the presentation, and our team from the Geoengineering Research Group will present our paper. Thank you, please. Video.
Assalamualaikum
Please, Mario.
warahmatullahi wabarakatuh. We are from Geoengineering Research Group of the Department of Civil Engineering, University of Mataram, would like to present our paper titled Application of the Updated PSHA on the Stability Analysis of the Meninting Diversion Spillway Tunnel in Lombok Island, Indonesia. The presentation is divided into 5 parts, which are introduction, tunnel design, method, result, and conclusion. Firstly, the introduction. As we already know that in 2018, huge earthquake occurred on Lombok Island, which erased almost 1/3 of Lombok and Sumbawa Island. During this series of shallow earthquake from July to September 2018, the seismic event has ruined thousands of houses and buildings in Lombok Island, including the Meninting Dam project, which is located in Dasangria, West Lombok District. The project was only at 50 km distance from the epicenter of the 3rd August 2018 earthquake. This current event occurred at depth of less than 30 kilometers, which were triggered by forest fault located at the north part of Lombok Island. The intensity of the earthquake event was from MMI 3rd to 9th and was MMI 7th at the project site, which caused some collapse area around the site. Probabilistic seismic hazard analysis PSHA for Nusa Tenggara region has been updated based on earthquake data of 1922 till 2018. Result in higher peak ground acceleration, spectral acceleration SS and S1 compared to those of SNE 17 and 26, 2019. Therefore, this paper recalculated the seismic design for the Meninting Diversion Spillway Tunnel according to current PSHA. Second, the tunnel design. The Meninting Dam located at Dasandria, where the 3 rock formation Kali Palung, Kali Babak, and Lake Kopiko covered the area. The sedimentary rock materials contain volcanic breccias lava per compacted volcanic rock materials of agglomerate and collivium. Most of materials were from erupted rock materials of Rinjani volcano. The Meninting Dam was designed to have two tunnel impact and diversion spillway. The diversion spillway tunnel was designed to be of two types, type 1 diversion tunnel and type 2 spillway tunnel. The type 1 was connected to the type 2 with connecting shaft to become a diversion spillway tunnel. The particular shoe shape type 2 was analyzed. The tunnel had dimension of 9.40 times 9.40 times 252.5 meters. The elevation of the tunnel base would be at plus 147.8 meter above mean sea level, while the top surface of the tunnel will be at plus 211.9 meter above mean sea level. The tunnel was planned to have fully support system, including wire mesh with a 0.15 meter thickness of the short grade, steel H-beam installed with a spacing of 1 meter, a concrete lining of 0.6 meter thickness, consolidation and curtain growth. Then Farfall stress P on the vertical and TP on the horizontal direction were estimated on each part of tunnel. A, B, C, D, E, and additional stress of the earthquake were estimated working on perpendicular to tunnel axis. So method, the construction of Meninting Tunnel followed the new Australian tunneling method. For the current stability analysis in this paper, the estimation of rock mass strength followed the nonlinear Hooke-Brown. Then the estimation of stress around the tunnel followed the Cree solution, where the field stress are P in the vertical direction and TP in the horizontal direction. A specific earthquake design standard for tunnel has not been established yet by BFNI, but two national standards are available for embankment dam and for building and non-building. The standard may be adapted for the estimation of earthquake force for the Meninting diversion spillway tunnel using the updated seismic parameter for Lombok and surrounding island to determine parameter for the peak ground acceleration of bedrock, short and long spectral acceleration. For the result, the Meninting diversion spillway tunnel was mainly excavated into volcanic breccias, which in general had a RMR of 40, which was included into poor rock mass quality. Thus, the stand-up time for the tunnel was 1 week without any support. Using this RMR value, MI of 19, and combining pressures on 0.06 MPa, the rock mass strength was within the range of 0.32 till 0.41 MPa, depending on the rock position on the tunnel. Such low Tangen 1 value were very much influenced by low combining pressures of 0.06 MPa. Also, a RMR of 40 did not really increase the rock mass strength as it should be. Then each part of the tunnel had a different stress concentration working on each part. The tangential stress works significantly on the crown B, crown C, base D. Shear stress concentration should be on the crown B and base D, while the crown A should be the tension, and some have might occur on the base E. When the earthquake force working on the tunnel were considered to be horizontally perpendicular to the tunnel axis, the influence of earthquake force on the tunnel depend on position of the tunnel. The earthquake stress on the peak crown A and base E were minimum. Otherwise, on the wall C were maximum of 0.04 MPa. Thus, this earthquake force result in increase of stress working around the tunnel. The updated PSHA provided higher peak ground, short, and long acceleration value, which resulted in higher estimation of the stress around the tunnel. From all estimation, the earthquake stress certainly increased radial and tangential stress working on the crown B, wall C, and base D. Particularly, Wall C was under high radial and tangential stress. Such tangential stress were up to 1.01 MPa. When the earthquake force considered to work on the horizontal line perpendicularly to the tunnel axis, the most deformed part of tunnel was the wall C. So after the completion, the construction, the tunnel had an increased factor of safety to become 2.0 over 2.0, although the wall C had still a lower value than other parts of the tunnel shown in table 5. The factor of safety value for the wall C estimated from the updated PGA was slightly lower for about 7%. Overall, factor of safety value may still be relevant to the tunnel, and the tunnel had fairly stability under earthquake, with an overall factor of safety of 2.5. The last conclusion, the recalculation resulted in reduction of the factor of safety of tunnel for all calculation procedure of the earthquake force for embankment, dam, and building and non-building design. The factor of safety reduction could be down to 35%, although overall stability of the tunnel should be fine regarding the overall factor of safety of 2.5. And the last, for future stability, the tunnel certainly requires some improvement since the current stability should be depending on the residual rock strength against possible similar surf earthquake. That's all from me. Thank you.
Okay, that's all from our presentation.
Okay, thank you for the next presentation, Mr. DDS Agusta Wijaya. Okay, very well, ladies and gentlemen. Now we come to question and answer session. There will be 5 minutes for this session until 1:22 p.m. Please mention your name and your institution. Any question? Maybe you can ask Mr. Didi directly, or you can type the question in the chat room, please. Does anyone? No? Okay. Mr. Didi,
Okay, thank
can
you.
you ask you?
Yes.
Okay. Does the analysis consider the direction of the earthquake for your tunnel? And what kind of software you use for the analysis, Mr. Didi?
All right, thank you very much. Yes, we consider the direction of the earthquake, the source of earthquake, and the main source at that calculation is from the northeast part of the Lombok, which was the Lombok earthquake 2018. So that's the most severe earthquake during the time. But for the updating the data, we use all data from 1922 to 2018, data of earthquake. Then we used updating data using the software of, sorry, I forgot the name, but this is from the BMKG used the data, so we worked with the BMKG of West Nusa Tenggara to recalculate the PHA. So that's the answer from me.
Okay, okay. Thank you, Mr. Didi. But is the what is the direction of the earthquake is parallel to the tunnel, or transversal from the tunnel, the
There
earthquake
is,
direction.
if you considering the earthquake 2008, the tunnel axis is relatively west east. Then the
Okay,
sorry,
I see, Joe.
no,
Yes.
sorry. The axis is, yes, a little bit on northeast, then make angle with the source of earthquake. So about maybe to 25 degrees from
Degrees.
from the axis. Yeah,
Okay, thank you, Mr. Didier, for your answer.
thank you.
Okay, maybe we have 1 minute more, but I think enough for the Mr. Didi is Agusta Wijaya. Thank you,
Thank you
Mr.
for
Didi is
having me.
Agusta Wijaya.
Thank you.
Okay, okay, thank you. Okay, ladies and gentlemen, let's welcome the second presenter, Mr. Yeri Kahaditu Firmansyah. Are you already near, Mr. Yeri?
Yes, already, Mr. Sapika.
Mr. Yeri Kahaditu Firmansyah will deliver a presentation entitled Slope Stability in Soft Soil Using Hardening Soil Modeling. Yes. Okay,
Yes.
ladies and gentlemen, please welcome Mr. Yeri Kahaditu Firmansyah. The stage is yours.
Okay, good morning, everyone. Today I will present about the result with the title The Stability of the Slope on Subsoil Using the Hardening Soil Model. And I am Yeri Kahaditu Firmansyah. The hardening soil model standard, or what can be abbreviated as is a continuation of the advanced soil behavior model, but the value or number of soil stiffness can be described, analyzed, and explained in more detail and accurately using stiffness. That is directly similar effort Arduino's whole triaxial load stiffness E15, triaxial loading stiffness EUR, and one-way load stiffness E odometer. Subsoil in Indonesia, composed of Holocene clay deposits which are obtained from volcanic eruption and effect of the properties of the soil. In terms of degree of consolidation, the average for deltaic clay in the Southeast Asia region can range between and begin 20% to 100%, depending of where the location is located. For sediment in the Indonesia region, for example, the grade of the alien is probate around 70% to 80%. This is all about the idea. First, there is one of the obstacles in embankment activity on of the soil is the number of landslides, especially if there is no reinforcing material available. And the purpose of the soil improvement is to search the component volume and the safe strength of soil, observe the modulus of soil, reduce the compressibility of soil, and etc. The last seed pile is a structural tool where it's designed to be able to withstand horizontal force when embedded in the ground. The seed pile can usually also be used on holding system. This is both calculation will be carried out the hardening soil or its model method. The criteria of more column shear strength will later limit the level of shear stress. The added model is entirely isotropic in terms of elastic strength and terms of elastoplastic. In its version, increasing the small strain stiffness is based on and depend on the stress and the accumulated shear strain. like this figure. Spot Reservoir Surabaya East Java. This is a location study. The water holding capacity 30,000 meter cubic. The alternative rainfall reinforcement talus area of the reservoir is uses corrugated concrete sheet pile CCSP type W 400 type A. Method. The CCSP installation method uses a check-in method. This method does not cause damage to surrounding building. This material is installed on the inside of the reservoir and surround the area with a type of material used is W500 type I. The figure like this. This is type material W400 type. The type I like this. Soil investigation. Result so that the condition of the soil layer has a very soft to soft consistency at the depth of 0 meters to a depth of 5 meters. 0 meters until 5 meters, very soft to soft consistency. The description of the layer 1. Layer 1 is inorganic clay with high plasticity, brown color, and layer 2 is inorganic clay with high plasticity with gray color. Review of the 8S based model. This is new construction, present and profit and unusual but specific algorithm govern the present hypoelastic rigorousness in the flexible assortment of the basic 8S model, like this. This is about formula. The first about mechanism of ferrotic plastic, mechanism of volumetric plastic. The second, the mechanism of volumetric plastic in the 8S model basic. Result in discussion. The safety factor is generally used to measure stability on a slope. In geotechnical engineering, is the study using failed element analysis was used to obtain the deformation, bending moment at GCSP, and safety factor that occur on slope. Slope geometry data will be modeled according to field data. This is input for finite element. This is load physical. This is GCSP W500 type A with length for 14 meter. This is stretching sequence. This is output, the first about bending moment, horizontal displacement, and force distribution. Conclusion from the talus stability model result the spot reservoir is not that the critical condition when the reservoir is dry or without water filling. This spot reservoir has the potential for landslide to occur if there is no reinforcement in the talus area. In order to avoid landslide, occur concrete sheet pile CCSP reinforcement type W400 type A with length of 40 meter. 14 meter. The safety factor value of the use of corrugated concrete sheet pile type W400 type A total length of 14 meter is 1.49. The use of the GSP W400 type A material as reinforced for the spot sport has taken into account several aspects, including when the reservoir is full water reservoir is empty, the load admin acute, and etc. Thank you. We would like to thank UPN Veteran Jawa Timur for taking investigation funding and the Chitaran developer and Mr. Bang. Thank you.
Okay, thank you for the interesting presentation, Mr. Yeri. Well, ladies and gentlemen, now we come to question and answer session. As usual, as we know, there will be 5 minutes for this session until 1:35 p.m. Okay, maybe please ask your question in chat, or you can ask Mr. Yeri directly. Don't forget, please mention your name and your institution. Any question? Please raise your hand if you want question to Mr. Yeri. Oh, there is Dr. Trisulistiawati here. Maybe you can ask to Mr. Yeri. No? Okay. I want to ask about your resume. In the first in the first your resume from the talent stability modeling result in the SEPAT reservoir, it is known that the critical condition when the reservoir is dry or without water filling. Yes, is that correct, Mr.? Can you explain to us why the phenomena is happen?
Yes, for this case, I'm already running about two conditions. The first, when I use wet condition, and the second when I dry condition. When I running with the wet condition, safety factor or SF, it's okay, 1.5. But when I'm running dry condition, this condition is failure. It's not okay. So I think, but this condition force between different condition in dilute is not good. I think it's between dry when different condition.
Okay, Mr. Yeri. I got one question from the chat room from the Mrs. Trisulistiawati. What are advantage this type hardening model?
Okay, thank you. Because there is the three dissimilar effort differences called triaxial load stiffness or E15 using stiffness and triaxial loading stiffness, a unloading reloading and one-way loading stiffness. So the hardening soil model method is proven to be more truthful and closer to field condition with case study in Java in Waduk spot. I think it's true.
Oh, are you satisfied with the presenter answer, Mrs. Trisulistiawati? Yes. Okay. Thank you for your question. Is there anyone to ask Mr. Yeri? But we have still enough for this time until 1:35, so it's more just 1 minute. No, there is no question. Maybe. Okay. Thank you, Mr. Yeri, for your presentation.
Mr. Saprika.
Yes. Okay. Ladies and gentlemen, now we are moving along to our session. Please welcome our the third presenter, Mr. Wait a moment, Dian Setiawan, but maybe here there is Mr. Firman Sharif, who will be speaking to us on implementation of microbially induced calcite precipitation by Bacillus subtilis and adding sand in repairing shear strength of organic soil with from Siak Regency Riau, Province, Indonesia. Ladies and gentlemen, please welcome Mr. Firman Sharif. The floor is yours. Your voice is not, maybe you can. Okay.
Okay, thank
Please,
you very
Mr.
much,
Firman.
Mr. Sepikayadi, for your chance to me. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, everyone. Before I start my presentation, please introduce myself. My name is Firman Sharif from Universitas Islam Riau, Pekanbaru in Sumatera. Today I would like to present my paper. The title is Implementation of Microbially Induced Calcite Precipitation, MECP, by Bacillus subtilis and adding sand in repairing shear strength parameter of field. Next.
Mario, please.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Today, I would like to present my result about implementation of microbially induced calcite precipitation by Bacillus subtilis and adding sand in repairing shear strength parameters of feed. Okay, before I start my presentation, give me time to introduce myself. My name is Firman Sharif from Civil Engineering Department, Universitas Islam Riau, and my partner is Dian Setiawan from Civil Engineering Department, Universitas Muhammadiyah, Yogyakarta. Today, my outline presentation are: first is background of research, the second one is material and method, third one result and discussion, and the end of the outline is a conclusion. Background. Feed. Feed soil is a type of soil with high organic matter content and high acidity. As we know, feed soil have many problems occur if we make a construction above the feed soil. Like here in the picture, we can see the road is broad, or there are some problem that happen in road above the feed soil. That's why one of the reason that we want to uh, research research is to solve the problem of its soil. Second one is Bacillus subtilis. Bacillus subtilis is a gram-positive, rod-shape, and catalyst-positive bacterium. Why we use Bacillus subtilis? Because from the paper that we read, Bacillus subtilis is microba that have applicability that can healing the problem itself. Like in our hand, if we have a wooden, and our hand can heal its wood by itself. That's why we use the Bacillus subtilis. The third one is biogrooting. Biogrooting is a new economic friendly stabilization method. Why we use biogrooting? Because we know in the world now, one of the big cases is chemical matter that can cause some problem in environmental or natural life of people, and also the other thing. That's why we come up with the bio-based material that can reduce the chemical matter that safe, and also decreasing the effect of chemical matter for the environment. The fourth one, we use compressive strength. One of the parameter that we want to know is compressive strength from the shear strength parameter. This method used to obtain how much the soil bearing strength is to accept the given commercial strength until the test object is separated from the grain and soil strength due to the pressure applied to the specimen. One of the problem is the in the subsoil is the low word compressive strength. That's why we want to solve the compressive strength become more better than before. Material method. Material here we of course we use feed soil that we get from the SIAC agency in Rio province, and also we adding some sand. The reagent here, the self-healing agent that we use in microbial industrial precipitation or biobuilding technique. Here we mix from the urea, calcium chloride, and also microorganism Bacillus subtilis as a growing material. We mix them and we can get
I'm so sorry, Mr. Firman.
Yeah.
The video that you sent to the committee is not moving. Maybe you can present manually.
Okay.
Okay. We will share the screen. Your presentation.
Just continue your presentation from this video, Mr. Firman.
Okay. Sorry. As the circle tabs can I use? Okay. After this slide. Okay. Material and method. For the material, of course, we use feed soil and adding some sands, and then we use a reagent. In this research we use from the urea, calcium chloride, and also the microorganism from we call it Bacillus subtilis as a growing material. For the method, the first one we do the preliminary testing, include the water content, specific weight, proctor test, and also seed analysis. After that, we do main testing. We do the UGS test for this research. Next. Okay, for the preliminary testing, we do the water content for the feed soil, and also we do the specific weight proctor test to get the maximum unit dry, and also the optimum water content that we that use for the making the sample of the soil, the feed soil, and also we do the seed analysis to know the characteristic of the soil. Next. The main testing, the first one, we make the bacteria reagent. So with the solution that I talked before, urea, calcium chloride, and also bacillus, we mix them, and then we get the bacteria, get the calcium carbonate from this reagent, and the calcium carbonate we use for making the sample of the feed soil before we do the UGS test. Next. This one, the UGS test that we do in this research. The test object is mounted on the load frame, so we put the sample here, and then we set the frothing ring, also the dial gauge here, the frothing ring and dial gauge, and we make the pressure velocity is taken as 35 millimeter per 15 seconds, and after that we begin to apply pressure until this sample collapse. And we make the documentation of this, and also write the result for the test. This is the main testing that we use for UGS test in the sample. Next. A result and discussion from the physical properties of the fit soil in Siak Regency, we get the specific gravity is 1.3, water content is 407.5%, unit dry max is 0.467, and the optimum water content is 157%. This one we use for the making the sample in the UGS test. And in UGS test result, we do some variation of the reagent, 0%, 5%, 10%, 15%, 20%, and 25%. And this one the result. We can see here the optimum Q maximum is on the variation of 15% reagent. So this is the result for the compressive strength. Next. So we make a relation between the value of the free compressive strength and also the variation of the reagent that we use in this sample. So we can see here the maximum is in the 15% of reagent. The compressive strength is 0.42. Next. From this result of the pre-compressive strength test sample of its soil using the UGS tool, with addition of variation in the addition of 5% sand and bacteria 0, 5, 10, 15, 20, and 25%, there is an increase and also decreasing in the strength of the pit soil. This is due to the addition of the subtilis bacteria sanitation solution, which can make the pore of the fit soil particle close or fill with bacteria, or fill with the region of bacteria and also the calcium carbonate, so that the fill soil does not easily decline. So this result, adding some amount of water on the region also can make the result become fluctuative like here. So in the next reset, I suggest that try to research about the water effect, the adding some water in the reagent effect for the result of the compressive strength. Also the pH among the carbonate that can produce from the reaction of bacteria and also the reagent. Next. We also make the comparison value of the free compressive strength with some other stabilizer like calcium 10% calcium carbonate and 8% maltose, and also preloading test. In here we can see from this table, from 10% calcium carbonate and 8% maltose give the higher compressive strength in our research, like here, higher than the preloading test. So in this research, we promise this research can be more developed because it use bio-based material, and in here in calcium carbonate and maltose use some chemical material that can affect the environment. So this kind of bio-gluting technique or bio-based material to improve the shear strength parameters is promising solution for less effect of environmental. Next. Okay, the conclusion from the result of the compressive strength of fit soil using a mixture of sand and also bio-gluting technique with the help of bacteria Bacillus subtilis. The result obtained in accordance with the research objectives are follow the relationship between the compressive strength and original soil plus 5% sand with variance in the concentration of bacterial fermentation solution at the percentage of 0, 5, 10, 15, 20, and 25%. The value of the free concept of the original soil test object plus 5% is 0.32. And the result is increasing, but the higher composite strength occurred in the 15% reagent or bacteria from the sample. Okay, maybe this is the result of our research on the biogrowthing technique. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay. Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Firman Sharif, for giving us such an informative and interesting presentation. Okay. Well, ladies and gentlemen, we come to a question and answer session. Mr. Firman, for question and answer until 1:53 p.m. Okay, please mention your name. So we have just 3 minutes for Mr. Firman Sharif. Anyone? Any question?
I have a question.
Yes, please.
Yes, please.
I'm Tantri from ITS Surabaya. I have two questions for Mr. Firman related with this research. First question is, has the use of this bacteria to stabilize the pit soil and also to increase the soil shear strength has been applied in the field? That is the first question for me. And the second is, are these bacteria not dangerous or harmful to the environment? Thank you. That's all my question.
Miss.
Okay. Are you ready to answer them? To answer the question from
Okay.
Ms. Putu. Okay, please, Mr. Firman.
Okay, thank you very much, Ms. Putu, for the question. For the first one, actually, this is the I can say this is the first reason for implementation the bacteria to the pit soil in my research. And also, I think in Indonesia, I never read the paper that implemented in the pit soil, but in the sand and also in the clay are implemented for the big condition of the industrialization, like in Japan, Europe, and also in Egypt. I have read they are implemented, but in pit soil, I think still not yet implemented for the industrialization. For the second question, for the bacteria, Bacillus subtilis that we get from the waste. I didn't write here because in next step I think we use from the waste from the oil palm empty branch, or we call it tangkos in Indonesia. We get it from that material, the bio-based material from the waste. Bacillus subtilis that I have read in the paper and also in the books. This is the bacteria gram positive. So the effect is in the environment is I think is less than the other bacteria. Yeah, but still we need to make a research for this kind of bacteria, because I not in a biological department, but I just get help from my friend from the biological and get the bacteria, but I come up with the idea of you can use this one and make this bacteria to the sample of soil. I think.
Okay, are you hello? Are you satisfied with the presenter answer, Ms. Putu?
Yes, but actually, as I know that it will be difficult to stabilize the soils in the field with materials, because we need a lot of materials, like what Mr. Firman did, that he need a bacteria, so meaning that if you use it in the field, so you have to, what is the name, spray a lot of bacteria on the field.
That's my homework, Mrs. Putu,
Okay.
because the art of my research for
Yeah.
now, maybe we just want to know how the impact of the bacterial. After it, maybe we can come up with the how is the optimum concentration of the material they can use in big field, or the implemented in the big case or condition, I think.
Okay. Thank you, Mr. Firman. Ms. Putu. Nice discussion, I think. Okay. Actually, there is one question, but the time is over. I'm sorry, Mr. Yeri Kahadi Firmansyah. Okay, thank you for presentation, Mr. Firman Sarif. Okay, now, ladies and gentlemen, let's welcome the first presenter. The first presenter is Ms. Putu Tantri Kumalasari. She will deliver a presentation entitled "The Performance of Horizontal Drain as a State-of-the-Art Landslide Mitigation Strategy, a Case Study Analysis." Ladies and gentlemen, please welcome Ms. Putu Tantri Kumalasari. The stage is yours.
Thank you very much. Do I have to speak for opening or directly to the video? Maybe it's better directly to the video.
It's okay if you want the speech first.
Okay.
After
Okay.
that, okay.
Okay. Thank you. Firstly, I would like to introduce myself. I am currently a lecturer in the Department of Civil Engineering ITS. My name is Putu Tantri, and in this occasion, I would like to giving all of you presentation about the part of my research entitled "The Performance of Horizontal Drains as a Landslide Mitigation Strategy," and you can follow it from the video recording. Please, committer. Good afternoon, ladies and gentlemen. Thank you for having me here. In this occasion, I would like to present the result of part of my research related with landslide mitigation strategy, entitled "The Performance of Horizontal Drain as a Landslide Mitigation Strategy." First of all, let me introduce myself. My name is Putu Tantri Kumalasari. I'm currently a lecturer in the Department of Civil Engineering ITS. Based on the data from the Disaster and Mitigation Agency, landslides were one of the most frequent disasters in Indonesia, especially in 2012 until 2014. Generally, landslides always occur when it rains, either immediately after the rain or during the rain. There are so many variations of embankment reinforcement methods that can be chosen as an alternative to landslide mitigation. Horizontal drain or subdrain is one of the efforts to prevent landslide by lowering the groundwater level, which, according to many researchers, is a cost-effective effort compared to other methods. The use of the good design of horizontal drain, according to the existing theory, is still very rarely done in Indonesia. In general, the installation of horizontal drain is only done based on the experience of successful work carried out previously and designed without reliable calculation. This study was conducted to summarize the procedure design and effective dimension of horizontal drain from previous studies, and based on those summaries. In this research, I analyzed the change in the safety factor of the slope with various soil parameters after the horizontal installation. So, what is horizontal drain? As we can see in the screen, a horizontal drain is a hole made by drilling a man-made embankment or natural slope covered by perforated metal or plastic pipe based on Reusser 1972. It is also defined by Barrett 1980 as a 1.5-inch diameter polyvinyl chloride or PVC pipe mounted horizontally or inclined through drilling to form a permanently installed angel. So, the use of horizontal drains, which serve to lower the groundwater table and for slope stability has been carried out for a long time. Early development of horizontal drain for road construction in California in anticipation of landslide date back to 1939 when the California Highway Division introduced the hydroger methods. Then the use of horizontal drain, both field scale and research scale, continues to be developed until now, as can be seen in the table in your screen. In the table is a summary of laboratory scale research and case study in the field that have been carried out since 1939 until now. Next slide. Oh, sorry. With so many cases that have been researched and carried out, there are several procedure design that are produced and used in several cases in the field. On your screen, in the table on your screen, you can see the result of the summary of the design procedure from the research and case study that have been carried out previously. It can be seen that the distance between the horizontal drain, the insulation depth, the horizontal drain configuration, soil slope parameter are important and evaluate the effectiveness of the horizontal drain design. With the horizontal drain, the groundwater level elevation can be reduced, with the reduced elevation varying depend on the soil parameters, rainfall intensity, and the topography of the area. Based on the result of the case study conducted by previous researchers, which are summarized in the table on your screen, the decrease in the groundwater level elevation varies from 1 meters based on Amatia and Mori to 15 meters based on the research by the Martin. The decrease in the groundwater level elevation can affect the value of the safety factor, of course, against a landslide and slope. Research conducted by Non-Filler 1981 showed, you can see from the table, showed that the horizontal drain increased the safety factor of slope value by 5 until 20%, while Tang et al. Showed the increment was up to 21.5%. Many other studies state that there is an increase in the number of safety factors with the presence of the horizontal drain, but do not write in detail the increase. This study calculates the increase in the value of safety factor with a decrease in the groundwater level with a different soil parameter. The result that can be seen in the right side of your screen, where the increase in the safety factor varies from 1 until 4% for every 1 meter drops in the groundwater level, while the value was observed to be up to approximately 20% for 9 meter elevations of the water level decrease. Then we arrive in a conclusion. After we try to summarize and analyze and comparing the result, we found 4 conclusions for the part of this research. The summary of the finding from the previous study showed that horizontal drain is an effective method to mitigate landslide, especially during the rainy season. It has been proven to have the ability of reducing groundwater level in order to increase the safety factor on the slope. This, however, depends on several factors such as topography of the location, soil parameter, and rain condition, and this is the reason for the difference in the groundwater level recorded in the location. The horizontal drain was also able to increase the slope safety factor for every 1 meter drop in the groundwater level, while the value was observed to be up to approximately 20% for 9 meters. Some other factors affecting the effectiveness of this method include dimension, the shape of the horizontal drain material, as well as the insulation space and length. This factor influence the ability of the drain to hold water and drain rainwater out of the slope. Moreover, the case summarized were observed to have different dimension, shapes, and result after the insulation, but both the field scale and numerical analysis proved. Good afternoon, ladies. Okay, that's okay. Okay, that's all my presentation. Is there any question?
Okay, thank you for the next presentation. Mrs. Putu Tantri Kumalasari. Very well, ladies and gentlemen, now we come to a question and answer session. There will be 5 minutes for this session until pardon. Let's see in the chat room for the question to 10 p.m. Okay, to 10 p.m. So we have 5 minutes more. Is there any question for a participant or a presenter? Another presenter? Please, you can type in the chat room or ask Mrs. Putu directly, please. Hello? On? No? Okay. Mrs. Putu, can I ask you about this your paper?
Sure.
In your conclusion, there is in the first conclusion, the summary of the finding from previous studies show horizontal drain is an effective method to mitigate landslide, especially during the rainy season. Maybe you can mention another method for to mitigate the landslides, Mrs. Putu.
Okay.
You can mention another method, maybe.
Yeah, thank you for your question, sir. There are a lot of such as geotextile, and then ground anchor, and seed pile, board pile. What is the name? Retaining wall, and so on. But there, I already explained it in my paper. But their methods is mostly effective only in a rainy season, only in a hard rainy season. But for in the dry season, that method is the slope have the safety factor more than 1.5 already, because they are not include the water in rainfall in the slope itself. So I said that that is not very effective for in the dry season. So this method is more cost effective pairing with another methods. These methods can reduce the water level, especially in the rainy season.
Okay, thank you, Mrs. Putu, for your explanation for us. Is there another question from the other participant, maybe? No? Okay. I think enough for Mrs. Putu session. Thank you very much for your next presentation, Ms. Putu. Okay. Ladies and gentlemen, now moving on to our system, please welcome our fifth presenter. Fifth presenter, Miss Siti Nurlita Fitri. Are you already here? Okay. Miss Siti Nurlita Fitri will be speaking to us on shear strength evaluation on analysis of additional clay linear layer modeling in Ngipik landfill Gresik. Is that correct? Okay, please welcome Ms. Siti Nurlita Fitri. The floor is yours.
Okay, thank you, Mr. Seplika, for this opportunity. I'd like to introduce myself first. My name is Siti Nurlita Fitri. I come from UNS Solo, and maybe for the organizing committee can play my video, please. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for having me here. My name is Siti Nurita Fitri. I come
Waalaikumsalam
from
warahmatullahi wabarakatuh.
Universitas 11 Maret, Surakarta, Indonesia. In this opportunity, I'd like to present my research entitled Shear Strength Evaluation on Analysis of Additional Collinear Layer Modeling in Nipik Landfill, Gersik. For the introduction, this is in the form of the new active condom fault located along Central to East Java with a strain rate of 0.99 to 1.93 millimeter per year. This further strengthens the importance of the local site effect in evaluating an infrastructure, including a landfill. Nipik landfill is located in Gersik, East Java, and the waste treatment system applied is an open dumping system without a protective layer. Meanwhile, one of the layers recommended by the Environmental Protection Agency, EPA, is the clay liner. This is a layer of cohesive soil with certain parameter, which is alternatively used to prevent leachate from contaminating the groundwater. The dynamic analysis, including simulation and evaluation, has been conducted on the landfill in several countries, and the results show the landfill has a significant contribution to groundwater pollution due to the large strain on the protection layer of the solid waste. This research was therefore conducted to determine the effect of adding clay liner to the new model of municipal solid waste in Nipik landfill through the use of dynamic analysis. Several models of clay liner were analyzed to determine the shear strength on the surface zone despite the existence of values from previous research in order to determine the effectiveness of clay liner construction. For the methodology in the bottom figure is SPT test, the SPT investigation of borehole 1 to borehole 3. So the soil has clay with different consistency, and this involves the soft and medium at the top surface, while those at 15-meter depth are dominated by stiff clay. Meanwhile, the soil stratigraphy was used to determine the properties needed for the landfill simulation models. In the left figure show the 5 models with different shape and approximately 115 to 160 meter width to be analyzed. Moreover, the addition of clay liner divided the cross-section of the landfill into 5 parts as shown in the right figure. Finite element model was used to analyze the behavior of the site due to dynamic modeling, while the dynamic property were determined using probabilistic seismic hazard analysis. Okay. The initial ground motion was used for the bedrock, while the nonlinear earthquake site response analysis on NERA software was applied to determine the ground motion to the models, the dynamic properties of the surface. Okay, and the third is result and discussion. The results of the study are presented in the following figure. The right figure show the shear strength parameter in the surface around profile 1. And the result of dynamic parameter in several conditions were discovered to have different shear strength value as indicated in right figure. The maximum shear strength was estimated to be from 6 times 10 to the power of minus 3 up to 10 to the power of minus 2. And according to Nakamura, the value where 10 to the power of minus 2 indicate the site is collapsed, and for the 10 to the power of minus 3 means there is crack and settlement. The summary of the result study is presented in left figure with the graph to illustrate the relationship between the shear strength and clay liner modeling in several profile of the solid was known.
All the profiles have the same trend of falling slightly for models 1, 2, 4. Moreover, the maximum chance in the addition of 2-meter clear liner as indicated in profile 4, while the minimum was 2%, as observed in profile 1. And next, the last is conclusion. The conclusion is clear liner addition in MIPIC open damping landfill was modeled in this study, and the results show similarity in all variations. The maximum difference was observed to be up to 40% of the existing condition, and this was discovered in 2-meter clear liner model. This means it's important to consider the use of the clay liner as a replacement material. It is, however, recommended that further study needs to analyze basic local site in different geological areas. Okay, this is enough of my presentation. Thank you for your kind attention.
Okay, thank you very much, Ms. Siti Nurlita Fitri, for giving such an informative and interesting presentation. Ladies and gentlemen, we come to a question and answer session. There will be 5 minutes for this session until, wait a minute, until 2:20 p.m. Yes, 2:20 p.m. So we have it's about 3 or 4 minutes for the question and answer session. Okay, is there anyone to ask Ms. Siti Nurlita?
I have a question.
Okay, please, Mrs. Putu.
Okay, thank you for the time. Ms. Lita, can I ask you about the clean liner function for the landfill? Is it also can increase the safety factor, especially to reduce the ability for landslide if we are using a clay liner?
Okay, thank you for the question. Bu Tantri is my supervisor at my undergraduate in IPS. Okay, let me try to answer your question. I can make sure that the clay liner is effective to increase the safety factor. But in this study, I have to modeling the shear strength to aim the clay liner modeling in shear strength value, not safety factor. And if you want to know that the clay liner is effective to safety factor, maybe in next study I will model for safety factor assessment. Thank you.
Okay, thank you, Ms. Lita.
Are you satisfied with the presenter answer, Mrs. Putu?
Can I have another question?
Of course, we have 2 minutes more. Okay, please.
You said that clay liner can increase the shear strength, so meaning that the cohesion undrained and also the fee of the landfill should be increased. Is it correct?
For this study, I just model with the dynamic analysis in Fluxys, and the output just the shear strength, and I don't change the parameter like C or V, and in the other words, the parameter is constant.
Oh, I see. Okay, thank you. Enough information.
Thank you, Bu Tantri.
Okay, nice discussion. Thank you very much. Okay, maybe enough for Miss Siti for this session. Okay, ladies and gentlemen, let's we next to our sixth presenter, Mr. Johnny Fitra. Are you already here?
Okay, I'm ready.
Okay. Mr. Johnny Fitra will deliver a presentation entitled Landslide Analysis Subject to Geological Uncertainty Using Monte Carlo Simulation, a study case in Taiwan. Ladies and gentlemen, please welcome Mr. Johnny Fitra. The stage is yours.
Okay, thank you for the time. Good afternoon, ladies and gentlemen. My name is Johnny Pitra. Today, I'd like to present our research about landslide analysis subject to geological uncertainty using Monte Carlo simulation, a study case in Taiwan. Play the video, please.
Mario, please.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. My name is Johnny Pitra.
Waalaikumsalam.
Today, I would like to present our research about landslide analysis subject to geological uncertainty using Monte Carlo simulation, a study case in Taiwan. The team research is Johnny Pitra, Professor Wen Chao Wang, and Professor Yosef Musli Purwana. The background of the research, according to a landslide occurred on highway number 3 near CZ, Taiwan, Republic of China on 2010 April 25. For the landslide, there is no rainfall or earthquake have been recorded before the event. The landslide may be due to the local infiltration of groundwater between the weak plains or the weakening of the slope stabilization facilities. The stability of rock slope can be assumed as molecular material as follows this equation. In this study, some assumption was applied for the equation. These are no cohesion was applied, no water pressure effect, and no anchor were applied to stabilize the plane. If the sliding surface contains no water infiltration and zero cohesion, equation 1 reduced to Fs equal to tangent pi divided by tangent beta. While a geologist does site investigation, one of the field parameter measurement is strike and dip of the possible sliding plane. Site investigation and ground description are considered as one of geologic model uncertainty. According to Zhuang et al. 2019, Keaton 2013, and Sullivan 2010. Various sets of dip angle that correspond to different measurement accuracy were applied in the plane failure analysis type of simplified slope failure. The method in this research is Monte Carlo simulation. The Monte Carlo simulation was used to quantify the effect of the geological uncertainty on the safety factor and failure probability. X source of dip angles with mean and standard deviation were employed to generate 100,000 dip angle samples. All the dip angle samples employed in the study were based on the highway number 3 sliding events in Taiwan. We assume that the distribution of all data source of dip angle and safety factors in this research was log normal in distribution. We calculate the safety factor using the generated random variables. After 100,000 repeat calculation, the probability distribution curve for the safety factor was obtained. The number of cases with a safety factor less than 1 and dividing it by the total cases were used to evaluate failure probability. Using Central Geological Survey (CGS) measurement, we found failure probability the measured CGS data is 78% and failure probability of the projected CGS is 63%. Using compass measurement in the field, we found failure probability of the measured compass data is 64.5% and failure probability of the projected complex data is 56.1%. Using surface measurement of the sliding plane after the event, we found failure probability of the measured surface data is 45.1%, and failure probability of the projected surface data is 42.1%. Furthermore, the last measurement method is LiDAR measurement. We found failure probability of the measured LiDAR data is 31%, and the projected LiDAR data is 16.9%. Due to this source high accuracy, the distribution of the deep angles is more concentrated than other source of deep angles. We can summarize the failure probability of the X source in the table 2. As on table 2 results, we realize that the failure probability values are greater than 10%, indicating a high potential for slope failure. If no stability measures were taken in the current analysis, we have assumed no anchor applied in the design. While in the actual design, anchor force were applied in the slope so that the safety factor is acceptable. Even the safety factor is acceptable when the anchor force were applied, the failure probability is still not acceptable. If the design is carried out only using CGS data, with failure probability of around 60% to 80%, engineer would like to bring the PF down to 0.01%. We can expect that the corresponding costs can be high. On the other hand, if the design is performed with the LiDAR data, it is evident that the required costs to bring down the original failure probability from 16% to 0.01% must be much lower than the case designed with CGS data. Thank you for your kindly attention.
Okay. Thank you for the interesting presentation, Mr. Johnny Fitra. Okay, ladies and gentlemen, now we come to a question and answer session. As we know, there will be 5 minutes for this session until 2:32 p.m. Please ask your question in chat, or you can ask Mr. Johnny Fitra directly. Maybe Mrs. Putu, can you ask us again?
Yeah. Because I have a question, but I think it's not so clear, maybe because I'm not yet with the research of Mr. Fitra. But my question is how to know, how to decide, or how to know which landslide, where is the location of the landslide area that could happen on the field. Can we simulation using the statistic like Monte Carlo to decide where is the specific area? Because as we know that to design the rainforest, we need to analyze the landslide. But there are a lot of landslides that have the safety factor under 1 or the safety factor unsafe safety factor. So my question is which area, which landslide area that can be using to design the reinforcement? Can we use by the Monte Carlo simulation too, or maybe you have a suggestion about that? Thank you.
Okay, please, Mr. Johnny.
For the area, we cannot use Monte Carlo simulation. Hello, can you hear me?
Yes, yes.
Yes.
For the area, we cannot use Monte Carlo simulation based on statistic. Maybe you can use another model to model it, like 3D or Texas, maybe. That's it.
Okay, thank you. Okay, because in Plexus is finite element, but what I say is about limit equilibrium. So I think we cannot use it Plexus to decide which area. Maybe Dex or what you say, or another method. But okay, thank you for your answer.
Okay. Thank you, Mr. Johnny. Maybe there's another question. Mr. Didi? No? Okay.
Pass.
Pass, okay. I think enough for Mr. Johnny Fitra for your next presentation. Thank you very much. Okay, ladies and gentlemen, now we move on to, let's welcome the seventh presenter. The seventh presenter is, wait a minute, Miss Ria Restumarla Nintias. Are you already in here, Miss Ria Restumarla Nintias? Hello? Mario, Excel?
Maybe we can skip to Mr. Windu Patono first. Mr.
Oh,
Yedi.
Okay. So now moving along to, please welcome the next presenter, Dr. Windu Partono, who will be speaking to us on software performance of risk targeted maximum consider earthquake MCER calculation. Ladies and gentlemen, please welcome Dr. Windu Partono. The stage is yours. Your time until just 7 minutes for presentation and 5 minutes for question and answer session, sir.
Thank you, Yadi. Can you see my presentation slide? Pak Yadi?
Okay, I can see.
Okay.
I can see that, please.
Thank you very much, Pak Yadi. Assalamualaikum warahmatullahi wabarakatuh. This afternoon,
Waalaikumsalam.
I want to share to the audience here about my experience working with the team for the system concept analysis and seismic preparation for the SNI earthquake. Okay, the title is about the software performance of the risk targeted maximum considered earthquake calculation. So why we use this title? Because now we only understand that already prepared the website software for the RTGM, and then the RTGM and the maximum considered earthquake MCR is already prepared in the website software. But when the software is finished, and then there is an effort from the team to prepare the what is they call it a single user non-website software, because this software is very important for the people or for the engineers who stay or who lives in the area with internet connection or problem with internet connection. So they asked to prepare, asked me to prepare the software, and the software not what you call it, not website based, and this is used for the single user software. So the before we prepare the software, so we have to understand the objective is to evaluate the performance of the standalone software, because we have two software, and both software can be used for the all engineers in Indonesia, and can be used for the design of the building. So we decided to evaluate, because the software is prepared with the consultant. So as the team of the Pascan, so we have to prepare evaluate the design of the preparation of the consultant. So this is the team for preparing the software, the website software, and also for the standalone software. So there is a consultant who prepared the software itself, and then this is the team that to evaluate this, the performance of the software. So basically, this is the performance of the website software. The team of the website software was prepared by the National Center of Earthquake Studies. And this is the first software that is already prepared and also finished. But when we finish this software, and then there is another information related with the design of the standalone software. So we already prepared the software itself, and then the purpose of the analysis is to compare how is the performance of the software, and then we check at the three location, the three this is Sumatra and then Java and Sulawesi. We choose the area because there is a lot of problem. There's an earthquake in this area, so we decided this area as a main subject for the evaluation. So so we have to check the how the consultant preparing or calculate the spectral analysis, and then this is the basic and the idea is for the calculation of the spectral analysis. They prepare two dimension of the interpolation analysis. I'm not want to tell in detail because there is four points here. There is 4 points here. So for example, if you want to calculate what is the for example the MTR in the SP point, so we have to analysis based on the 4 points here, and then the distance between each point is about 110 degrees or about 11 kilometers. So and then we have to check. This is the analysis. This is the analysis we calculate manually, and then the manual calculation. So and then we have to check the performance of the software created by this consultant. So this is the example of the calculation of the MT peak ground motion, peak spectral acceleration. And this is the method where we have 4 points, and then we calculate the PGA of the consultant software. And then this is another sample for the another location using 4 points again, and then we calculate the same method for the data that we calculate manually, and then we check the result calculated by the consultant. So this is the result. This is the result of the software created by the consultant. So this is an example of the Sumatra. There is 154 data, and there is three example here. This is a PGA. This is as our short period spectra, and then this is the long period, 1 second spectra. And then if you look here, the product of the consultant, there is a problem related with when the peak ground acceleration is more than 0.6 g, and then this is another problem when the acceleration is greater than 1.5, and also this is for the 1 second spectra. We got a problem here. So this is we evaluate in for Sumatra, and then we check the number of difference. So when we calculate this data, and the difference is about 100. So the difference is 110. So the difference is small. Yeah, it's small, only 3% for PGA, and then for this is only 7. But we have to check another calculation based on the 100 difference. So there is a big difference. There is a big difference for PGA, and then for the SS value, and also for the S1 value. So we got a problem here. And then we follow the previous data and graph. So there is a problem related with the point of the data located where the value of the acceleration is greater than 0.6 or 1.5. So and then we have to check, and we have to check the distribution. So we make a cross section here. We make a cross section here. This is a simple cross section at the Sumatra Island, cross section AA. And then we got here that there is an unstable data. This is an unstable performance of the software at position 6. And then position 6 is about close to the seismic fault, seismic fault area. So we had a problem when we calculate the software created with this consultant. So please be careful with the manual software, because the manual software is a little bit unstable when the position of the building is close to the seismic source area. This is a Sumatra. This is a Sumatra area, and then we check again in Java. We check at the 150 data, and it's a little bit better compared to the Sumatra, because you know that there is a little bit a seismic source in Java. So this is the same condition. We got a problem with when the PGA is greater than 0.6, and then this is a little bit unstable when the acceleration is about 0.6, and then this is another problem when the acceleration is about 1.2 or 1.3. This is and we check again, and the performance is much better. The performance in Java Island is much better based on the difference greater than 110. Yeah, this is okay. But when we check again, when with the difference is 100, so a little bit problems. But this is less than 10%. Is I think is much better compared to the Sumatra Island, because basically there is no strong data in Java Island. So this is I think this is the reason why the data at the Java Island is a little bit better than compared to the Sumatra Islands. And then we make a cross section here, and the performance is the same. This is the area where the data is the big data at the West Java Island, and then we check here. This is at 0.4, and then this is close to there is a seismic fault here. Yeah, this is so I think there is a problem with unstable data between two software. Yeah, and I think it's compared to the Sumatra data, Java is much better. Yeah. Okay, and then the last one is at the Sulawesi Island. We check here 81 data, and then you know that the Sulawesi Island is a dangerous area. There is a lot of seismic happen in this area, so we have the same problem like a Sumatra. So we check here, for example, for the PGA, we got a problem when the software calculate the data, calculate the acceleration spectra. So the data become unstable here, and then also for the 1 second period of the acceleration, we got a problem with the software, and also for the 0.2 second acceleration. This is a problem when the value of the acceleration is greater than 1.5. And then we check again. So again, when we check the difference of 110, so the difference is okay, looks is okay. But when we check with the difference is 100, so the difference is almost equal to Sumatra Island. So we got a problem here. We got a problem when the software calculate the MTR located, for example, in Sumatra, and then this is in Sulawesi, and maybe in Papua. So we do have a problem with the manual of with the single user software. So we have to because this software is going to share to the all engineer in, and then before we decided to share this software, so we have to recheck again because the software is still ongoing evaluation, especially for the standalone software. So we have to I think it's better to not to use for the moment for this software. If maybe you got the software, so be careful with the software itself, especially for the standalone software. But for the website, it's okay. You can use. I think it's better use the website software. So this is the like Sumatra. This is a problem related with the data close to the seismic source area. Yeah, we got a problem here. So this is the problem related with the three kinds of acceleration. Okay, and the conclusion is that the signal difference of the MCR data, there is a three data, MCAG, and then SS and S1 calculated using a website and using a standalone software. We got that a problem at Sumatra and Sulawesi Islands, the coordinate position. And so the difference when we calculate with the difference of the both software is about 0.100. So the difference is a little bit bigger. So because we can use 110 because when we use 110, so the calculation of the this three acceleration is a little bit different. So I think we decided to use the difference between two software is not less than not greater than 100. So this is we have to evaluate again the performance of the standalone software. So we have at the moment, I think it is better to use the website software. So I think this is for Java Islands. I think it's okay. Yeah, less than 10% difference between two software, but we still have a problem because when the software is calculated, the difference between two software is about 9%. So I think 9% from the whole data is at we speak. So this is a problem, and this is the experience of my experience working with the team for the preparation of the website software and then also for the standalone software. I think that's all. Thank you very much for your kind attention. Thank you, Pak Yadi.
Okay. Thank you very much, Dr. Windu Partono, for giving such an informative and interesting presentation. Okay, ladies and gentlemen, actually our time is just until 2:45 for Mr. Dr. Windu Partono. So at now 2:48. So if is there any question, just for one question, I think. Okay. Any question?
My question, Pak.
Okay, please, Mr. Yosef.
Okay,
Yosef, please.
good presentation for Dr. Windu. He's expert in electrical engineering, I know.
Yes, of course.
Okay.
Thank you, Masle.
I have to learn from you much, Pak Windu.
No.
Okay, I have some question actually, Pak Windu. So in this paper, you are studying about the performance of the software, aren't you?
Yes.
Okay. In my point that the comparison between website and software is actually depend on the approach inside. Maybe maybe model inside.
Yes.
You mentioned that in some cases it will be almost similar, but in some cases a little bit different. Can you explain what is the reason, the similarity or the difference between them? Have you checked the formula inside, maybe?
Yeah, thank you very much, Prof. Masliti, because actually, as a consultant, we can get the formula because this is a secret formula. because the software itself we cannot open the software, so we cannot open the formula inside the software itself. So what we are going to do is we have a manual analysis. So whatever the system, whatever the formula used by the consultant, so at least we don't care about it. But we have like a manual formula. This is all of us agree with this formula to calculate, to analyze the data, because we use the same data. We use the same data. Consultant and the team is use the same data, and then the difference is about how to calculate, for example, the acceleration. So at least we don't care with the consultant who create the formula, but we have a formula, and then we check, and then we agree with our calculation, and then if we agree, so the consultant have to change. That's a simple method to check, and also to check this both software. I do create the software itself, yeah, and I do create the software itself, because when we doing with the data, for example, more than 10,000 data, yeah, and then we have to create a software. So I did create the software using the Visual Basic software, and then the value is almost equal when we calculate the manual, and then we calculate with the software is okay. But when we got a problem with when the consultant prepared the software, especially for the single user software, because we have a problem, because the single user software will use for all the engineer when they got a problem with maybe with the internet connection. So I think we have to be prepared with this software. But for the website, I think it's okay, because the website, we check the website output is okay. I think the result is okay. I think something like that. Actually, we don't know about the formula used by the consultant, but all of us here, the Puskan team has a formula, and then we check and then it's okay. And so I think this is the condition, real condition when we check the software. I think like that, mostly.
I have a question, Pak Yadi.
Okay, please, Mr. Didi.
Right.
Okay,
Interesting.
very
Pak
interesting. Please.
Dr. Windu, it seems that the software is much influenced by big fault like Sumatra fault and Palu fault and the Cikidang in West Sumatra. What is the approach to solve a problem, maybe to make the line smoother, Pak Windu?
Yes, it is a good question, yeah, because all of the data of the different, the largest difference was observed at the position of close to the seismic source location. So we have to make a smoothing analysis. So I think we already prepared the analysis, and then actually we create, for example, we create what if we create a formula itself, and then we compare my formula with, maybe you understand, Professor Wayan Sangara, they create a software itself, and then maybe you understand, and all of the team create the software, and then all of us is check this the internal software, and then what is the method to calculate the data is, I think this is a little bit secret. Just a little bit secret, because we don't care about the formula, but we have this simple figure, yeah, like this one. The consultant said only like this one. So for example, when we want to get the space subject at SP, so we have to calculate, to interpolate four data with a linear two-dimensional of the four data, and then when I ask to the consultant, so this is the secret of the software, so they don't ask how to create a smoothing of the data. So I think it's okay. That is the output of the outcome of the software is much better than the compared to the formula itself. I think hope it is is you happy, Pak Didi?
Thank
Yeah.
you. And about the other parts of Indonesia, like Nusa Tenggara and Maluku and Papua?
Yeah. I do believe that when the calculation take place in maybe in Papua, we will get the same problem. The software, yeah, I think because I think Papua is like a Sulawesi, like a Sumatra. But when we compare with Java Island is there is not no strong earthquake source in Java compared to the Sumatra or compared to the Sulawesi. So the value is a little bit stable. Yeah, but when we doing the research in Sumatra and then we compare, in comparing Sumatra and Sulawesi, I think when we compare Papua, the same thing we will get the same thing like a Sumatra. I think like that. Nusa Tenggara is, I think it's okay. Nusa Tenggara, I think it's okay because I think the problem is related with when there is a seismic source located at the main island. This is a problem. When there is like a Sumatra, there is a fault inside the island and also in Sulawesi. But Java, there is a fault, seismic fault in Java, but the data is not so strong compared to the Sumatra and Sulawesi and also for the Papua. I think this is the reason.
Okay, maybe next time we discuss a lot about this. Thank you, Pak Windu.
Thank you very much.
I think it's expert discussion here. Thank you, Mr. Windu, Mr. Didi, and Prof. Yusef for the nice presentation.
Yeah, I'll be learning from Dr. Windu, inshallah.
Yes, of course.
Yeah.
Okay.
Thank you.
Thank you, Mr. Windu Pranoto. Actually, we have one more presenter, Mrs. Riarestu Marlanin Tias. Are you already here, Mrs. Riarestu Marlanin Tias? Mario?
Pak Yani, unfortunately, Resto is not available at the moment, and based on the information from Pak Mario, the video is not also available.
Okay.
So unfortunately, I don't have any PowerPoint at my computer, so I'm sorry for that because I'm also the member of the presentation, the paper.
Oh, okay. Thank you, Mr. Didi.
Thank you.
I'm sorry. Okay. Ladies and gentlemen, finally we come to the end of our parallel season on day one. I would like to say thanks again to all the presenters for their informative and interesting talk, especially at the in the Mr. Windu Pranoto session, and the audience for your active participation. Okay, hopefully the seminar will be beneficial for everybody. Amin, and thank you for your attention. Please give applause to our invited speaker and you all. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Terima kasih, Pak Yani.
Thank you. Thank you for everyone.
Selamat Pak Windu.
Thank you, Pak Musli. Nice to meet you, Pak Musli.
Oh yeah, kami.
Okay. Thank you. Mario, maybe.
Yeah.
Okay. Assalamualaikum warahmatullahi
wabarakatuh. Pak Windu, saya pun belajar sama Pak Windu nih, lebih jauh lagi Pak Windu.
Maka saya ini masih Pak Musli. Jadi saya ini kan lagi menyiapkan buku panduan untuk para studi tentang gempa.
Para pelajar. Saya pesan satu Pak Windu.
Ya, insya Allah. Ini masih disiapkan timnya masih menggodok ini. Jadi nanti kita akan di-share semua karena memang ini kan pembelajaran. Jadi selama ini kan seperti saya di kemudian di UNS itu mungkin pembelajaran tentang hazard gempa ini kan sedikit ya. Jadi banyaknya menghitung, kita hitung bangunan kena gempa dan lain sebagainya. Jadi begitu kita tanya, loh kamu dapat gaya gempanya dari sini, dari mana? Pertanyaan itu kan sering tidak bisa dijawab.
Ya, betul.
Itu tidak bisa dijawab. Jadi kemarin saya juga diskusi saya juga ini mau presentasi di Tarumanegara. Jadi ini terjadi Pak Muslih. Jadi apa namanya? Kalau saya punya bangunan, selama ini kan bangunan didesain pakai response spectra SNI, gitu Pak Muslih. Nah, kenapa tidak pakai time history?
Iya.
Nah, kalau time history itu kan sebenarnya data gempa sesungguhnya.
Iya, iya.
Nah, itu apa namanya? Ramai, berbatalnya ramai.
Betul, Pak Windu. Ya perlu dijelaskan Pak Windu. Ada pertanyaan, kenapa short period itu 0,2? Kenapa 1 detik gitu? Itu juga harus dijelaskan Pak Windu.
Oh ya, itu cuma choice saja Pak. Jadi choice saja. Jadi kesepakatan bersama. Jadi kita bisa pakai 4, bisa juga seperti itu. Jadi kita akan mengacunya ke American Code ya. Jadi American Code itu pakainya kan PGA 0,1, 0,21 gitu kan. Kemudian sekarang ada TL begitu kan. Itu ramai juga. Jadi ramai juga.
Itu perlu dijelaskan Pak Windu di bukunya.
Iya, pasti ada penjelasan. Nanti semuanya kan ada penjelasan karena kan kita sekarang kan kita ini tua-tua gitu kan, tapi tanggung jawab ilmunya mana yang
pokoknya ceritanya dijelaskan, kenapa begini itu ya kadang-kadang di buku nggak ada. Ya kita tunggu bukunya Pak Windu.
Ya, ini masih pasukan Pusken sama PU PR ini sedang bekerja keras ini.
Iya, terima kasih Pak Windu. Saya untuk di Nusa Tenggara itu mengupdate sendiri Pak Windu.
Oh,
jadi
Pak.
Ya, karena saya melihat kemarin setelah gempa Lombok itu banyak berubahnya itu.
Betul.
Sehingga kemarin saya dengan BMKG ada melakukan studi begitu, kemudian kami melakukan updating data lah untuk SH di Nusa Tenggara. Memang ada perubahan dari yang kita kenal selama ini begitu, baik melalui PU ataupun yang melalui SNI itu kita lihat karena datanya itu kan kalau Nusa Tenggara baru sampai 2000 yang terpublish begitu sampai 2016.
16 betul.
2016 dipakai 2017 kemudian muncul untuk SNI 2019 ya.
Sementara SNI 2019 itu pakai gempa 2017 loh Pak.
Iya, tapi datanya sampai 2016,
ya,
Pak.
Betul.
Ya, sehingga ketika ada gempa 2018 itu kan itu data belum masuk, padahal itu berubah semua hampir tatanannya. Walaupun memang naik, tapi artinya perubahan naik itu kan untuk sebuah satuan gempa itu lebih besar itu.
Iya.
Ya, sehingga saya mengupdate sendiri dengan tim
Iya, bagus Pak, itu bagus sekali Pak kalau bisa.
Ya, karena kalau kita menggunakan seperti Bapak tadi sebutkan yang sudah publish sampai 2011 dari Puskim itu, nah itu kan tidak cocok itu, sehingga tapi saya belum melakukan yang verified menguji ke berbagai macam daerah di Nusa Tenggara. Saya coba menguji untuk di Lombok dan Sumbawa dulu karena untuk ke tempat lain kan kita harus butuh seperti tadi Pak Windu yang lakukan untuk Sumatera harus butuh data banyak gitu untuk melakukan pengecekan. Tapi
kalau
menarik.
yang ini Pak, yang softwarenya sendiri itu sudah mengakomodir Pak. Softwarenya website itu sudah mengakomodir data yang terbaru.
Yang 2000, ya.
2018
tapi belum
sudah ada Pak.
Tapi sudah muncul di website-nya?
Yang website-nya Pak. Jadi nanti coba di website-nya Pak, yang website yang tahun 2020 Pak ya, yang punyanya ini Pak, yang punyanya Cipta Karya. Sekarang kan yang pemiliknya bukan Puskim tetapi Cipta Karya.
Oh, sudah. Oh iya dialihkan.
Ya, jadi yang dipakai yang di Cipta Karya. Jadi kemarin ada gempa-gempa itu juga sudah mulai sedikit dirubah di lokasi-lokasi di mana terjadi gempa tahun 2018 di Lombok ataupun di Sulawesi. Ya, Palu ya Pak. Ya.
Baik. Baik, terima kasih diskusinya Pak.
Iya Pak.
Kita di Lombok karena terancam dua, ini sumber gempa besarnya ada di utara dan di selatan.
Atas dan utara dan selatan kena Pak. Cepit Pak.
Iya, itu
Besar-besar semua itu, Pak.
itu dia. Ini yang
Besar-besar semua.
betul, betul, betul.
Saya pernah presentasi di di apa namanya di tata ruang, Pak. Jadi tentang Lombok. Jadi
Ya.
tata ruang dengan Lombok. Tapi presentasinya di Bali.
Jakarta.
Di Bali, Pak, di Bali. Jadi
Di Bali,
apa namanya?
ya.
Karena pas apa? Kemudian saya presentasi tentang likuifaksi.
Ya.
Potensi likuifaksi di Pulau Lombok itu ya, di Lombok itu.
Okay.
Nah, itu mereka antusias sekali.
Ya, ya.
Ya, jadi di situ ternyata Lombok ada potensi likuifaksi, Pak ya. Jadi itu yang
secara potensi dimungkinkan, tetapi mungkin secara histori geologi itu tidak seperti di Palu.
Palu, betul, Pak.
Ya, secara karena Palu itu khas untuk sejarah geologinya gitu. Kalau di Lombok itu tidak mirip karena lebih banyak lapisan gunung api yang muda begitu.
Betul,
sehingga lapisannya ada di permukaan.
Betul. Jadi likuifaksinya memang berbeda dengan di Palu, Pak.
Berbeda.
Tapi memang saya sampaikan kemudian ya ini potensinya memang tidak sehebat Palu
Ya.
atau tidak sama dengan Palu.
Tidak sama.
Tetapi kalau pada daerah-daerah tertentu memang itu perlu diperhatikan adanya potensi yang kecil-kecil itu apa namanya terhadap likuifaksi gitu. Jadi
iya, kalau untuk ininya ya, untuk awareness begitu ya.
Ya, awareness betul Pak.
Ya, baik. Terima kasih Pak.
Oke Pak, ya saya ini mau presentasi lagi Pak.
Ya. Baik, terima kasih. Sampai ketemu Pak.
Salam warahmatullahi wabarakatuh.
Tes sound. Mungkin ada panitia yang ada di ruangan.
Nggih, Bu. Nggih, Pak. Maaf, sudah masuk, Pak.
Oke. Yang pakai akunnya Pak Yusuf ya?
Pripun, Pak? Mohon maaf, bisa diulangi?
Halo.
Nggih, Pak.
Dengan teknisi ya, Mas.
Iya, Pak. Operator, Pak.
Operator ya. Oke.
Atas nama Pria Restu.
Ditunggu sebentar nggak, Pak? Nanti sampai 15.15.
Ya, saya mau cek sound aja. Saya keluar lagi sebentar sampai jam minum. Apakah suara saya sudah terdengar baik di sana?
Sudah, Pak. Sudah masuk.
Oke, baik. Saya leave dulu sebentar ya, sholat dulu. Setelah itu saya nanti on time jam 4.15 masuk ya.
15.15, Pak.
15.15.
Ya, 3.15. Ya.
Terima kasih.
Oke, terima kasih, Pak.
building is inseparable with rehabilitation and maintenance. Rehabilitation and maintenance in civil engineering is as important as planning and designing. Rehabilitation is defined as the effort to regain building and infrastructure's function once defected or weakened, while maintenance is the effort to keep the building and infrastructure working as planned. The Department of Civil Engineering 11 Maret University, in collaboration with the Department of Civil Engineering Mataram University, proudly present to you the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering.
Civil Engineering Department of 11 Maret University, in collaboration with other university partners, organized the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, or ICRMCE. This conference is initially scheduled to hold offline in Mataram, Nusa Tenggara Barat, Indonesia. However, due to the escalating COVID-19 outbreak and the need for social distancing, we finally decided to shift the conference online. This conference is providing a forum for researchers, academicians, government agencies, consultants, and constructors to exchange experiences, technological advancement, and innovation regarding rehabilitation and maintenance of buildings and infrastructures. The previews for ICRMCE were successfully held in 2009, 2012, 2015, and the last one 2018, respectively. We hope that the ongoing conference will be a success and will serve as a positive step forward in the future. Stay healthy, and we look forward at the conference.
The Civil Engineering Study Program, University of Mataram, was born on November 8, 1991. The Department of Civil Engineering is supported by field of expertise of lecturers is divided into 5, 4 which are lab-based, plus the field of expertise in construction management. Until 2018, 2,243 civil engineering graduates have graduated. Civil Engineering Diponegoro University was established in 1958 to meet the needs of civil engineering experts in Samara. The curriculum for the Bachelor of Civil Engineering program at Diponegoro University is designed so that graduates are able to understand the concepts. The Department of Civil Engineering Universitas Jember is part of its Faculty of Engineering. At this time, the Civil Engineering Undergraduate Study Program is accredited A by the National Accreditation Board for Higher Education. Universitas Jenderal Sudirman. The Department of Civil Engineering was established simultaneously with the Bachelor of Engineering program, which was the forerunner of the Faculty of Engineering, UNSUR. Civil Engineering UPN Veteran East Java has facilities in the form of 5 laboratories. Universitas Muhammadiyah Yogyakarta. UMY's Civil Engineering Study Program is one of the first study programs held when Muhammadiyah University of Yogyakarta was established in 1981 and has received the accreditation of Grade A. Utama Karya is a construction company whose
I'm sorry, Mr. Fajrin, your microphone is still muted.
Sorry. Thanks, Mario. Um, I think we can start right now, as already few participants already in the room. Thank you very much for joining us in this great conference, the 5th ICRMCE International Conference on Rehabilitation and Maintenance in Civil Engineering. This year, this conference is focusing on the topic Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering. My name is Johar Fajrin, a senior lecturer at the Department of Civil Engineering, Mataram University, Lombok, Indonesia. As part of several sessions that held in this conference, I will be moderating this parallel session, which is focusing on earthquake-related matters. It's based on your topics that shown in the rundown. Just a quick note, this parallel session will be recorded, so please be aware of it. If you have your camera on, make sure to turn it off if you don't want your video to be shared in social media later on. But I recommend it that turn it on. And on behalf of the committee, I would like to extend very welcome to all of you in this afternoon. Before we start these sessions, I outline the rules. There are actually only one or two rules here. That the first one is presenter will be allocated more or less 12 minutes in all. That consists of 7 minutes for video playback and 5 minutes for Q&A section. And then for the Q&A section, the question, please use the chat room provided by the committee. All right, ladies and gentlemen, now I would like to introduce our honorable speaker and presenter today. Actually, based on the first rundown, he had only 5 speakers that will be presenting their presentation in this afternoon. And the committee just informed me, let me know that the order will be changed slightly. According to the first down of the session, we will have 5 speakers in this parallel session. The first one, Dr. Windu Partono. Good afternoon, Dr. Windu. I just noticed you just present in the first parallel
Mr. Fajrin,
session.
excuse me, Mr.
The
Fajrin.
committee will put you on the back.
The last one. The last one. Okay.
All right.
The last one.
Okay. And then the second one, we will have Mr. Doni Rohmat, maybe. And then the third one, Dr. Niken Silmi, the owner of this conference. And the fourth one, Dr. or Mrs. Win Lestari. And the final will be presented by Muhammad Zainal Arifin. All right, fellow researchers and speakers, I'm not holding you any longer. Now we start with the first speaker, pre-recorded video, and then followed by Q&A answer from the first speaker. So please, I think Andini, Mrs. Andini, could you please present your video presentation and then followed by our Q&A session. Now the floor is yours.
Hello everyone, I'm Salsabila Ramadanti and now I'm going to present the paper by Mrs. Andriani, Mr. Bayu Martanto Aji and me, Salsabila Ramadanti. And the title of the paper is Analysis Impact and Mitigation of Landslide Disaster using the Analytical Hierarchy Process or AHP method. Landslide disaster. Landslides are the movement of slope-forming material in the form of rocks, scrap material, or mixed material that moves down or out of the slope. In 2018, Indonesia was ranked first as the country with the most disaster victims in the world and was ranked second after Haiti as the country with the most victims for the last 19 years. Indonesia's natural conditions such as topography, geology, and climatology are the dominant factor causing disaster, the movement of land masses. Methodology. The first is literature review. Literature review are carried out by searching and studying various written sources, whether in the form of books, archive, magazine, article, and journals. The result of this literature review will be used as a reference to strengthen existing argument as well as a reference for making research questionnaire. The second is questionnaire. The questionnaire was distributed to experts from universities in Indonesia, where these experts had more than 10 years of experience with landslides. The third is data processing. This data management uses the AHP method and the Likert scale. The fourth is the result. From the result of data processing, an analysis will be carried which will have the dominant impact and the most important mitigate landslide. And the last is conclusion. In the AHP method, a hierarchy structure is used. Hierarchy structure is a structure that simplifies a problem by grouping it based on the level from a problem based on a literature review. And in this paper, there are two hierarchy structures. The first is the hierarchy of landslide impacts, and the second is the hierarchy of landslide mitigation. In the hierarchy structure of landslide impact, there are three levels. At the first level is the goal, that is the most impact of landslide. And then the second level is criteria, that is casualty impact, physical impact, and environmental impact, and socioeconomic impact. And the last level is sub-criteria. There are four levels in the hierarchy structure of landslide mitigation. At the first level is the goal. That is the most important landslide mitigation. Then the second level is criteria. That is mitigation before landslide, mitigation during landslide, and mitigation after landslide. Then the second level is divided to be structural and non-structural. And the third and the fourth level is sub-criteria. HP method process. The AHP method is known as a decision-making method based on the assessment of human perception who understand the existing problem. And also, the AHP method is also often used for assessment of decision problem. There are 6 stages of the data processing using the AHP method. The first is assessment matrix. The first step then must be taken for the assessment matrix is to compile a Powers comparison, then transform it into a Powers comparison matrix for numerical analysis. The Powers comparison scale uses a scale from SATI. The second is normalizing data. Data normalization is done by comparing the value of each element in the pair matrix with the total value of each column. Priority factor. Determining the priority value requires a comparison of the total rows in the matrix and the row total is generated from the sum of the total row values of the calculated that has been compared with the total value of the matrix in each column. Next is maximum eigen. And then consistency. The difference between the AHP method and other decision-making methods is the requirement of absolute consistency. The consistency is also determined by the maximum eigenvalue. If the repair rate matrix having a CR greater than 0.1 was considered inconsistent, an expert assessment could not be used. And the last is Guillemot. After testing the consistency of the hierarchy, the next step is to combine opinions or assessment of the questionnaire that are consistent using the average or Guillemot. Likert scale. There are 3 stages of data processing using Likert scale. The first is validity test. Validity test is a test measuring tool or question used in the questionnaire. Tests are carried out to find out whether the question used are correct to perform the musing function on the questionnaire or not. And the second is reliability test. Reliability test is a test conducted to determine whether in the test equipment or question used are consistent or stable if repeat measurements are met. The third is data processing. After testing the validity and reliability, the next step is processing data on assessment using a Likert scale, like on the screen. Based on the result of data processing using the AHP method, it was found that the most dominant impact occurred was the impact of casualties with a weight of 0.358, and the lowest weight was the socioeconomic impact of 0.157. The weighting value obtained is in accordance with BNPB data for 2015 until 2020, which show that the impact of casualties is mostly caused by landslide. The result of the assessment show that mitigation measures before landslide occur have the greatest weight value compared to mitigation effort during and after disaster. Based on the result of assessment, the most significant impact and the most important mitigation of landslide are related. Because the mitigation carried out is a mitigation that can reduce or even eliminate the greatest impacts of landslide. Conclusion. First, the impact of landslide is classified into 4 parts, namely the impact of casualties, physical impacts, environmental health, and socioeconomic impacts. Second, landslide mitigation is classified based on time, in which there are 3 divisions of landslide mitigation. Mitigation before landslide, during landslide, and after landslide. Mitigation before, during, and after landslide is classified into 2 types, namely structure and non-structure. Structure mitigation is an effort taken to reduce the risk of landslide by building physical infrastructure and technology approach, while non-structure is an effort made using policies or regulation. Third, the assessment by 14 experts from universities in Indonesia using the AHP method result in the impact of being affected and displaced as an impact with the highest weight of 15.35. This impact was included in the classification of casualty impacts. Meanwhile, the impact that is not dominant according to the expert is the impact of crime with a weight of 6.75 and is one of the socioeconomic impact. Fourth, assessment by 14 experts from university in Indonesia using the AHP method result in the 2 most important mitigation measure with a weight of 11.29. The first mitigation is the creation of a map the location of landslide disaster and easy to reach evacuation routes, and the second is the creation of a landslide early warning system and the installation of a rainfall monitoring device. Both mitigation are included in the mitigation classification before landslide.
Thank you, Dr. Andiani. It's very nice talk. I didn't notice any question in the chat room. Does anyone want to ask question? Please use the chat room anyway. All right then, if nobody has anything else to ask or to add, now let's move to the next speaker, which is Dr. Niken Selmi.
Excuse me, Mr.
All right.
I apologize that Buniken cannot join this room right now. And I, as the co-author of the paper ID 63, will try to handle the discussion part.
All right, then let's replay back the movie or the pre-recorded video of the Niken's articles.
Okay, thank you.
Okay, you can start right now. The floor is yours.
My name is Niken Silmi Suryandari. I came from UNS. In this opportunity, let me explain our research entitled Influence of the Number and the Hex Steps of Terrace Model on Slope Stability Analysis. Wonogiri is an area that has a high volume of vehicles, such as motorized, private, public, and logistic vehicles. This condition because Wonogiri is located in the border area among East Java, Central Java, and the special region of Yogyakarta. This area also has susceptibility to landslides due to its topography. The landslides occur are not only due to the weight of the slope itself, but also because of excess external loads, specifically traffic load. Many methods of slope reinforcement have been carried out in Indonesia. For example, soil nailing, gabions, vegetations, geotextile, and terracing. Previous research has used improvement with terracing. This strategy will develop with traffic loads as external load analysis. The most critical safety factor of slope stability analysis in previous study has become a reference to improve the new models in this research. The study simulated three types of traffic loads. There are first type, load use the road pavement, plus the load of two trucks on both roads. Second type, is same models with the previous type, but addition truck load in one path. And the third type, load use road pavement load only. The safety factor value has been analyzed with limit equilibrium methods. There are 10 variations of terrace models which calculated in this study. It can be seen from this slide. The result of slope stability analysis were done in two types of modeling conditions. The first is before and after rain, and the second is in the conditions before and after terracing. The existing slope are 30 and 60 degrees. Based on the analysis, there is an increase in traffic loads during the rainy season. The safety factor has decreased in value when the slope becomes steeper. The analysis carried out in rainy conditions shows that all safe numbers are below the safe value required by police. Therefore, when the rain conditions, the vulnerability of landslide in the study area is high. Addition of the step effects on the value of safety factor. This is indicated by the trend line which always increase in each graph. The more the number of steps in the slope, the soil mass on the slope is also cut. Thus, the vulnerability of landslide is also low. In rainy conditions, the number of steps affect the speed of rainwater flow through the slope. The more steps in terracing models, the slower the speed of the rainwater flow, so that the slopes are not easily eroded by rainwater. Terracing is proven to increase the slope safety factor with traffic loads. This is evidenced by an increase in the safety factor with its increase in the number of steps. That's all my presentation. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Niken or Mbak Siti Nurlita Fitri as the representative of the team right now. I also didn't see any question in the chat room. Probably does anyone want to raise question for this topic? Or probably because it's already afternoon, so everyone's already. One, two, three. Any question, please? Or maybe later on. Again, thank you very much for the interesting talk. Now let's me move to the third speaker for this afternoon, which is Mr. Muhammad Jainal Arifin. So I'm not holding you any longer, so the floor is yours now. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning to the reviewers. I will present our paper entitled Seepage and Piping Control of Field Dam, Case Study of Indonesia Bidukso Dam, on the agenda of International Conference on Rehabilitation and Maintenance of Civil Engineering. Firstly, I will introduce the author of this paper, including myself, Muhammad Zainal Arifin, Joseph Musli, and Raden Haryan. Our paper is a case study of the Bidukso Wonogiri Dam, which is located in the Bidukso village, Giro district, or Wonogiri Regency. The dam is a plan for national water and food security program covering the irrigation area of 1,500 hectares, increasing the intensity and a source of water around 300 liters per second for the many big city. The groundwater is needed for the safety of the dam from the seepage and piping. If we don't attention, can cause the dam failure. The following is a diagram of the dam failure incident driver ASDSO incident database 2010 until 2019. We can see that seepage is the most common cause of the failure. Preset is a picture of the dam failure Brazil do the seepage. From this reason, the paper entitled Seepage and Piping Control of Field Dam case study of Indonesia Bidukso Dam. This picture explains geometry section of the Bidukso Dam, and the dam consists of the 6 material, namely it filled with a permeability of 10 to the power of -7 and 8. And following the methodology of this paper using 2 main formula, namely the safety factor formula and the Laplace equation. From these 2 formula, the basis for using the SIP-W software can be readily considered in a seepage analysis. Seepage analysis was carried out on 3 alternative interactions of extended seepage control, with curtain grouting, cut-off wall, and upstream blanket, with 4 models: origin length, and the second 2 divided 3 from scheme from models 1, and the third 1 divided 3 from the model 1, and 2 divided 3 from model 1 with doubles in the upstream and in the downstream of the dam. This is the description of the additional seepage control. The first curtain grouting is the injection of the adhesive material into water permeable soil or rock with the aims of closing process and the fracture so that soil strength can increase. And the second cut-off wall as a water retaining coal obtained from a mixture of concrete, and the upstream blanket as a horizontal extension of the core zone with the same material and the coefficient of permeability. This is the following are used result and discussion. The first is the result of the analysis without the additional CPS control. We can see the safety factor 6.32, so it can be concluded that the dam is safe from piping. The amount of the set 1,206.60 meter cubic per day. So it can be concluded that the dam without additional seepage control safe again volume seepage. The following are the result of the seepage control with cut-off wall. Analysis using the main formula referring to the PUPR 20 and 5 guidelines that the depth of cut-off wall to impervious soil, which result are used as a scheme 1. This picture is the result of a set exit gradient analysis of cut wall and the depth 30 meter is scheme 1. For more complete analysis result from various scheme are presented in the table and the graph. We can see the biggest seepage reduction percentage is scheme 1 is 42.42% is scheme 1, and the larger cut-off wall, the less this. The following are the result of the seepage control with curtain growing using the main formula according to PUPR 20 and 5 is the adjust scheme 1 until 4. This picture is the result of the exit gradient analysis of curtain growing. For more complete analysis from various scheme are present in the table and the graph. We can see the biggest seepage reduction percentage is scheme 1. It is 67.82% is scheme 1, and the larger the curtain growing the less in this page. The following are the result of the seepage control with upstream blanket analysis using the equation according to SNI 80652016. This picture is a result of exit gradient analysis of upstream blanket. For more complete analysis, results from a various scheme are presented in the table and the graph. We can see the biggest seepage reduction percentage is 8.4% is scheme 1, and the larger to upstream blanket, the less the seepage. The following is comparison of the seepage discharge result from the installation of additional seepage control, which can be seen in the table. The scheme most reduce the amount of seepage is the scheme of adding curtain growing with ideal length. Finally, this is a conclusion of my paper. The first, the stability of the bidex dam method and with the installation of additional seepage control to the safety and seepage magnitude is safe, which is less than the allowable seepage discharge and safe against of the piping. The second, and the larger the addition of curtain growing cut-off wall and the upstream blanket on the foundation of the dam, so the smaller the seepage discharge from the dam. The third of the several alternative additional seepage control, then alternative cut-off for 30 meter is the most effective alternative to reduce seepage up to 67.82% of the dam. Thank you very much for your attention. Matur suwun. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for the nice and clear presentation, Mr. Zainal Arifin. If anyone has any question, please raise your hand maybe, because again, I didn't see any question in the chat room. Wow, this is interesting. All right then, probably we can come to Q&A later on. So now I think the best way is just to please the full presenter in this afternoon, which is Dr. I think it's the time for Dr. Windu Partono. Please welcome to Dr. Windu Partono. So the floor is now yours. Thank you.
Thank you, Mr. Fajrin. Let me share my presentation paper.
All right. So we'll live anyway.
Yeah, okay. Can you see my presentation, Mr. Fajrin?
Yes, we see now.
Okay. Okay, the topic of my presentation is related with seismic microresonation of Jakarta province based on the 2019 risk targeted maximum considered earthquake. This is related with the previous presentation, which is concerned with how to make how to calculate the maximum considered earthquake. And in this presentation, I want to share my experience when we are doing the SNI, preparing the SNI 2019, and we applied this method for the design of for the calculation of the microresonation of earthquake in Jakarta province. Okay. Jakarta province is located close to the active seismic source of opaque fault which cross to the province area, and the south subduction source which located at the south part of the Java Islands. So this is the two source earthquake that it's a very dangerous earthquake source close to the Jakarta province. So based on the data developed from the previous earthquake. So there is a big earthquake, 2006 earthquake, with magnitude is about 6.2. And then the problem is related with a lot of buildings. It's about 88,000 buildings were collapsed or destroyed, and also a lot of buildings is collapsed. So this is a real problem related with 2006 earthquake. So the improvements of earthquake research have already conducted in this area, and the latest research related with the development of the seismic map 2017. And then according to this research, we already prepared the new Indonesian seismic code 2019. And the purpose of this presentation is to share or to look forward about the real condition of the Jakarta province when we calculate the risk of the province according to the Indonesian seismic code 2019. So this is the Jakarta province, and this is the data developed for the 2006 earthquake. There is a lot of epicenter data collected from the earthquake. So this is a real problem when we got the earthquake data, earthquake epicenter. There is a lot of data that we can get from the epicenter of the earthquake source. Yeah, this is a real problem. Okay, and then the method we calculate is combination analysis of the probability and probability analysis and deterministic analysis, and the last one is risk targeted considered earthquake. This is the three different methods used for the calculation of the maximum considered earthquake that we want to use and we want to explain in this area. This is the basic idea of how we calculate the three different methods for development of the MCR here. So I don't want to discuss this because it's very complicated. And then this is the first idea is we have to calculate the probability approach. Yeah, this is the probability approach of the analysis when so we can get the uniform hazard ground motion. This is the first. Usually we can calculate for the earthquake hazard, uniform hazard ground motion. And then the second one is related with the deterministic analysis. So when we calculate with the deterministic analysis, actually this is almost equal with the probabilistic, but the deterministic, we calculate the Hazard value according to the maximum magnitude and the closest distance of the earthquake source. This is, but when the probability is applied for the calculation of the earthquake, and then we got a lot of probability that we can apply for the analysis. And then the third method that we use for the calculation of, we use for the analysis is related with the race targeted ground motion analysis. This is developed by Luca in 2007, and the basic idea is when we calculate the seismic hazard. So in this problem, we have to make sure that when the actual earthquake happen in one area, so with the same magnitude, so the risk should be equal. So Luca said that we have to apply another probability that we can based on the building collapse. This is the modified of the probability that we use 1% of the possibility in 15 years. Okay, this is I don't want to. This is as a formula, and then this is an example calculation. So this is an example of calculation how we can get the RTGM. This is the risk targeted ground motion. The calculation based on the Hazard probabilistic. This is the Hazard probabilistic, and then we can calculate, and then we can find the risk targeted conversion. This is an example. Calculate 3 different positions in Jakarta province, and then this is an example. And then if we compare the value between the RTGM and the probability PSA here, and then we got the coefficient. We call it risk coefficient is less than 1. It means that when we use the probability itself. So I think the value is a little bit bigger compared to the rates that we can apply to the analysis, and then the value is less than the probability itself. Okay, this is another example. Okay, and then this is a method of when we want to calculate the RTGM. This is the purpose of the RTGM is the analysis is applied the possibility of building collapse 1% in 50 years. This is the analysis. This is just an example analysis that we from this analysis we can get the RTGM value of the 3 different positions of the Jakarta province. And then this is the same method. Yeah, we use 3 different analysis. This is the deterministic, and then this is the probabilistic, and then we got RTGM. RTGM is developed from the probabilistic, and then we combine this analysis to get the MCR spectral acceleration. And then this is the to make a calculation. So we first make a cross section here. A cross section in 13 points here, and then we use the 4 different and 3 different methods. First, we calculate the probability analysis, and then the second one is the deterministic, and then the last one is the RTGM. Yeah, and then based on this value, we can calculate the maximum considered earthquake of the 3 different positions, and based on these 3 different positions here, so we calculate the whole area of the Jakarta province, and then we can create the microzonations of the area based on the last one, the maximum considered earthquake rates at the Jakarta province. And this is another spectra. Yeah, we use the 1 second spectra, and then the previous one is 0.2 spectra. Yeah, okay. And then this is the result. This is the result of the microzonation of seismic hazard in Jakarta based on the maximum considered earthquake. So if you look here, this is the PGA of the Yogyakarta. So the maximum possible of maximum considered earthquake that could be happen in Yogyakarta is about 0.6. This is a dangerous area, the green area close to the opaque fault area, opaque fault force. This is the maximum value of the acceleration that could be applied to the city. So that this is I think this is the important area that the seismic should be taken into account. This is outside of the city of Yogyakarta, the central city of Yogyakarta. So it's okay. And then this is the PGA, maximum considered earthquake in PGA. And then the second one is also the same, maximum considered earthquake. This is for 1 second earthquake spectra. This is the value is almost equal with the previous one, with the maximum is about 0.67 G. And then the area is almost the same with the previous one. But for the short period, 0.2 second period of the spectra, this is the maximum considered earthquake is up to 1.5. This is so it's mean that when we design the building close to the opaque fault area, so we have to careful with the building itself, because when there is a if we design the building based on this area, so this is we have to take care about all of the building located close to the opaque fault. And we on the fortunately is close outside the Yogyakarta city. So, but the same area, this is the important area that should be taken into account for the province of Yogyakarta. So, based on this condition, this is the microresonance of the Yogyakarta province. So, the conclusion is that the seismic microresonance of Yogyakarta province was conducted based on the risk-stratified maximum considered earthquake by combining the different approach. This one, the first one is probabilistic, and then the second one is deterministic, and the last one is risk-targeted ground motion analysis. So the analysis was developed based on the earthquake data used for the Indonesian earthquake maps 2017. And then the maximum considered earthquake, that is maximum spectra for maximum considered earthquake. There is 3 different spectra for the PGA, and then for the 2.2 period, and then for the first period of the spectra, we observed that the detected within a 10-kilometer radius from the line of the opaque fault. There's a little bit dangerous area for the building design. So we have to make sure that the design of this area should be completely analysis based on the new data calculated for the SNI 2019. This is about 10 kilometers. And then also for the values, maximum is 1.5 G for the short period of spectra. This is when we decide to make to build the building close to the opaque fault area. So we have to care about the maximum spectra about 1.5 G. This is a very big spectra that we have to take care about this value. And also we predicted that the maximum spectra acceleration area associated with the opaque fault was detected at a radius about 10 kilometers from the opaque fault place. I think that's all. Thank you very much for Mr. Fajrin. This is my presentation. Thank you.
All right, thank you very much, Dr. Windu, for the nice and very clear presentation this afternoon. Ladies and gentlemen, please, does anyone have any question? Again, I didn't see any question in the chat room. Or probably I can start, just, to fill up the time with one question, Dr. Windu.
Yes.
As I saw in your conclusion, it include numbers, and it's very difficult to find what is the value of this research. I just would like to ask, what is the actual beneficial of your work for the society? Just probably in very simple and short sentence.
Yeah, thank you, Mr. Fajrin, because this is a real problem we got for the data for Yogyakarta based on the 2017 maps. Yeah. So basically, there is two different earthquake sources close to the Yogyakarta. First is Opak Fault, and based on the map 2017 map, the Opak Fault was designed to 6.6, I think, magnitude, and also for the subduction in the south part of the Yogyakarta province is about 8.4 or 8.5. So based on this condition, so if there is an earthquake, for example, if there is an earthquake that the earthquake is close or greater than 6.5, because the previous one is 6.2. So when the earthquake is greater than 6.5 or maybe close to 6.5, so we have to take care about the red area that the acceleration is or the acceleration is too strong, I think, especially for the society, because you know that the problem of our society is because for the old buildings, the oldest building, because the building is not designed based on the earthquake or the SNI earthquake. Yeah, this is a real problem. So we have to take care about the old houses. But when we design the building based on the SNI, for example, from 2002 until now, I think all of the engineers in the Yogyakarta province has already designed the building is as strong as what they need. But the problems related with the old buildings, because based on the experience of 2006 earthquakes, a lot of building collapse happens for the original the simple building like a house. Just a lot of buildings collapse, not structural building like Ambarukma Hotel or maybe Yogyakarta University. A lot of high-rise building in Yogyakarta, but still okay because the building is already prepared based on the SNI. But the problem related with the public buildings, this is a real problem. I think it's something like that.
All right, thank you very much. That's quite very clear answer. Yeah, the problem with the building is for the old one and then also the low-rise building.
Yeah.
The high-rise building is already designed based on SNI. I think that will be fine for them to stay safe during the earthquake attack. Yeah. Anyway, thank you very much, Dr. Windu, for the nice presentation. And then as I didn't see again any question in the chat room, now let's move to the last speaker in our parallel sessions today. Thank you very much for your presentation, Dr. Windu. And then I would like to invite the last presenter today, which is Dr. or Mrs. Wien Lestari from ITS with their article about foul structure interpretation on the western part of East Java using second vertical derivative. So please, the floor is yours, Dr. Wien Lestari.
I'm so sorry, Mr. Fajrin.
All right.
Mrs. Winestari videos is not available on us, and Mrs. Winestari did not join the Zoom.
Then they join the Zoom as well.
I'm sorry, Mr. Fajan, could you repeat the statement?
I think it's not here. I think
it's not here. We didn't
yeah, it's
see
not here
any.
because
Okay, all right.
according to the participants here, there is no. This is
yeah, no,
it's not in. I
nothing.
think yes.
All
It's
right,
not.
all right. All right, then, thank you for all the 4 presenters today, ladies and gentlemen. Now we come to the end of our parallel session. We would like to gratitude to the presenters for the informative and interesting talk this afternoon, and also for the audience for their active participation during the parallel session. Hopefully, the presentation will be beneficial for everybody. Thank you once again. And before we closing, we would like to take a screenshot for all participants. So please turn off your camera, please. And then the committee will take the screenshot. Already?
Not yet, Eddie.
Not
Mr.
ready.
Fajrin. I think not all the participants stay. I think only 2.
Yeah,
Yeah.
so it's
Okay,
10
I think we
participants.
wait for 1 minute again, maybe.
All right, okay. So please join and then turn on your camera, please, just to take our screenshot for this parallel session. I don't think they will be here. So it's okay.
Okay,
Please
keep going.
take the picture, please.
Okay.
1, 2, 3. 1, 2, 3. Again. Again, hopefully the presentation will be beneficial for everybody, and thank you very much again, and see you next time in the 6th ICRMCE probably in the next couple of years. Good afternoon, everyone. Thank you and goodbye. Assalamualaikum warahmatullahi wabarakatuh.
Salam, Pak Fajrin. Thank you very much, Pak Fajrin.
Yeah, terima kasih, Pak Windu.
For your kind presentation. Yeah, I think it's okay. I think.
All right, already left some presenters. Can I chat or talk with the committee, please? Anyone inside the room? All right, then I will leave the room as well. Thank you very much for the good parallel session in this afternoon. See you next time. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore. Good afternoon.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you so much, Mr. Fajrin.
Yeah.